Okay, good evening, everyone. This session we have planned for the OPP that mock we have released. So we will discuss about the mock solutions and also we will discuss about the important topics for the OPP preparation. I hope everyone have seen our announcement also. So we have also shared some important topics, important area where you need to focus more for this exam and also posted on the discourse. So that you need to prepare on that topics only. So we generally not ask very big topic or big implementation in the OPP exam. So I'll discuss some important topics and at the same time we will also cover our mock solution. Before starting the session, if anyone have any query, you can also ask. Okay, you can open your mic and you can ask your query.
Okay, sir.
Okay. Second. So this is the first OPP. Actually, we have only one OPP in this course. So you are going to give this exam first time for PDSA course. So some things you should know very that's are important for this OPP exam. First thing, just open your exam in the new UI. Okay. So we have also set, I think by default, new UI will be open. Uh, I hope you all know that about the new UI of the course page.
Yes, sir.
Uh,
Yes, sir.
so just run your project, run your exam on the new UI like this. Okay. Because some old UI has still some issue. So like button disappear issue. Sometimes what happen if someone print any long input in one line. Suppose if someone is running a for loop, infinite loop type of thing, and that loop is printing something in the one line. So in that case, that portal page is actually distorted, and buttons are actually disappear. So do not use old UI. Uh, okay, try to use this new UI only in the exam. Also, many of the time we found that many of the students reported this something went wrong and not able to run type of error during the OPP exam. So that is also most of the time that error also comes due to the bad code logic. Okay, so suppose if you are writing something some logic and that code is actually not stopping. Okay, that code is continuously running without stopping. So in that case, after some time, portal actually gives this type of error, something went wrong. So, but many of the students reported that this is the portal issue or something. This is not our code issue. This is the portal issue, and they just asked to the proctor. And proctors are also not the technical, too much technical persons. So they may also don't know about the portal. So at that time, they also just ask to the team. So this process actually takes too much time, and your time is also wasted during this process. So something went wrong. Just if you are getting this type of error when you are clicking on the test run button and submit button, so just see your code and see your logic carefully and try to correct your logic if you're getting some infinite time of execution type of thing. Okay. Same thing, not able to run. So that is also a some runtime error issue. So that also comes due to the some code error or something. So in that case also just focus on your code without wasting your too much time during the OPP exam. Okay, you can validate the portal running things by just clicking print statement or this type of statement. If that question statement is asking something to return by the function, so you can simply write return one like this and see portal is working or not. So you can test the portal working without wasting your time if you're getting some this type of error, something went wrong and not able to run type of error. Okay, so these are the some important points. So just focus on this during the exam. Do not waste too much time to communicate with the proctors regarding this. Okay, and another thing is what are the important topics. So let me cover quickly again. So most of the time in the that OPP exam, The first topic is actually which most of the time one question comes from this linked list topic. Okay, so linked list. So you should know how to create a linked list, and during the creation we follow some insertion operation. So insert a new element in the linked list. Okay, so linked list we create with the help of that class object, this thing in the Python. So how we can insert a element in the linked list, and so this things can be done in three way. So insert at the first position, uh, and last position, and any given position. Suppose k, this position is given, kth position, just insert a new element. So this type of operation regarding the insert, same type of operation regarding the delete, delete element from the list. Okay, and insert and delete. Then to perform this operation, you should also know the traversing. Okay, traversing operation on the list. If a list is given, so most of the time some structure will be given to you. So structure will be most of the time of only that singly linked list. So some head will be given, and head, then each node will contain the address of next node like this. Okay, maybe there is a chance you will also get a tail. Okay, that will contain the address of last node, and that last node will contain the null value in this none value in this next field. Otherwise each node will contain the reference of another node. So structure will be given. So you, first thing, just check the structure properly, and after getting the structure, also see that what information you are getting directly. So you will be get this head that is pointing to the first node. If a tail is given, so that will be point to the last node. Then suppose if any operation is asking like insert the node at the last position, so you can directly use this tail, and you can simply connect the node with the help of this tail and perform your task. Okay, but after performing the task, so what sometimes what happen, so many of the students actually not update this reference properly. Suppose if you are adding a new node, and by mistakenly you are not filling this as a none value. Okay, and some garbage value is coming in this, or some by mistake you mention a wrong address. So when our that suffix code, hidden suffix code will traverse this list, that that will not find, actually none will not be findable in this list if it is not properly mentioned. Okay, so if you are performing any operation, suppose if you are removing, deleting this node, and you are connecting directly this. Okay, so in this case, suppose if you are not updating this address to none, then suffix code will read this node also. Okay, so properly update the address. So after this inserting and deleting element, your structure should maintain properly. The what structure is given in the equation, that structure should maintain after the operation also, after deleting the element, after inserting the element. So that is the required things in the linked list type of question. So you can expect one question definitely from this part in the exam. Okay, and question your understanding should be properly about the traversing, inserting, and deleting. Then you can perform any type of operation on this. Okay, so some questions are also given in the mock paper regarding this linked list topics, so that we will discuss. Otherwise, just practice on this part, how we can insert, how we can delete, and how we can traverse properly. So that part you should know for this. So this is the one. Second, second is binary search related questions. Okay, binary search related questions. And not, I am not asking that exact binary search. Okay, so not exact binary search, but binary search concept based problems. So where you can apply the binary search concept. Binary search concept means if any problems comes on this topic, so definitely questions solution will be asked for log n complexity. Okay, you can identify that if question is asking the solution for log n complexity, then you can directly think about this binary search concept. Okay, on that problem.
Okay, sir.
Okay, one second. So log n complexity and log n in the binary search concept, always think about that how you can divide the problem into half every term and discard the half part and check the next half part. So this question will test the efficiency also. Maybe suppose if question is simple like searching the element and you are just applying the linear search. So that in that case, your maybe some public test case will be passed because some public test case will be given as a sort like only 10 elements or 20 elements, because that elements you can check and you can validate the your solution that your code is working on the 10 elements or not. Okay, but that will be passed by the linear solution also and the binary search solution also. Okay, but to test properly this type of questions, long test case are also configured. So that test case will contain like 50,000 in size input or maybe 1 lakh size input. So okay, so the size will be high for the another test case. So or most of the all private test case will be the high length size to test the login solution properly. So just write a efficient solution of log n complexity. Okay, and in binary search implementation, do not use slicing. Okay, so that we have also mentioned in our notes and we have also mentioned during the live session. So do not use slicing in the binary search solution because slicing operation internally takes order of n time. If you are implementing binary search, definitely use simple while loop logic, or maybe if you're using recursive logic, so just pass the list as it is and use the variable start index, last index, mid index. Use the index to divide the part of the that input. Okay, so do not use slicing to pass the in the recursive call. Okay, so that is the one important things. If binary search is concept is required, so just write a that efficient implementation for this. One more important thing, sometimes what happen, so that is not always, but sometimes what happen if your solution is very close to the required solution. Okay, suppose in the millisecond, suppose your required solution is taking 0.000534 and your solution is also very close to this, like 514, this type of situation that comes very rarely. So in that case what happen, maybe some random behavior you will get. Okay, so maybe in the one first run, uh, 4 out of 5 test case pass, this type of problem will come. Okay, but generally we set the time like this. If we require this log n time, we will just set time approx like 5 times of this. Okay, your solution
Okay.
should be less than to the like suppose this time is we are taking t, and we will just set this as like 5 or 6t time, and your solution should be less than this. Okay, in the log n case, so then
Okay, sir.
your test case will be pass. If you are writing a linear solution, definitely it will not pass. Okay, it will be very high compared to this. So that time will also be display for the some public test case. If your test case is not passing, so we will display some that time, your time and required time, that will display in the output. Okay, if your test case is failing due to the time issue. Okay, efficiency issue. So that will be a display for the public test case. But sometime random behavior, so you can just try to run your code 2-3 times. Okay, so just click on the submit button. If you are just seeing 4 out of 5 pass, then click once again. Okay, then maybe if your efficiency issue is there and you have written the log n time solution, so that test case will also be passed. If we are continuously, if you have tried 2-3 times but it's still not passed, so definitely some logic error is there. Okay, so test your solution in in this type of case. Test your solution, just click 2-3 times on the test run button or submit button. Okay, so otherwise most of the case that if you are getting continuously this some test case fail, so definitely some corner case you are missing, and improve your logic. So that is important thing regarding the binary search based problems during the OPP exam. Yes,
Sir,
someone. Yes.
So your slicing means like getting a list from I colon J like that, right?
So what happen if you are writing okay, let me show you that that implementation is also discussed. Okay, B2. Hmm. Okay, so this is not. Uh, this is also not. This one. Okay. So you can see this implementation. Here we have actually using recursive approach, but we have passing the slicing. We have passing the list after the slicing. Just give me a minute. One second. One call is there. Yes, sorry. Okay, so this type of implementation, you can see we are passing this list in the recursive call, but we are passing that list using the slicing, so that how list will be passed. But that list will be the new list, not the same list. Okay, so that means what operation we are doing internally, we are copying the half of the element in a new list, and that list we are passing in the recursive call. So
Yes.
copying the half of the elements in the new list, that takes a linear time. So that means n by 2 elements you will copy. So n by 2 operations will be performed. So that will take order of n time. So because of that, we mentioned that do not use this. Okay, in the that any exam. Okay, but we have alternate approach without. So this is the one recursive approach where we are passing the same list L, but we are indicating that which next part we will check again with the help of this start index, high index, and searching element. Okay, so low and high, this value we are passing. So we will use this index. Okay, otherwise see, this is a simple while loop process of the binary search. So most efficient is this one. So this is the most efficient in the binary search, and this is next. This is also a log n, but this have some recursive cost additionally. So if you know this while loop, so this will provide a efficient solution in the binary search concept. Okay, but you can also use this. So yeah, this is the binary search related things. Next is, so you can practice some questions. We have already covered some questions in the your course assignments, live coding sessions, some binary search related questions. You can practice on that, and you can also search some more questions. Third is one question definitely from the graph. Okay, so in graph week 4 and week 5, so BFS is the most important one implementation. So that actually check the cycle, that checks the connectivity, that checks the levels. Okay. So if you know the BFS, some questions may be framed on this type of topic. So it's like connectivity check and that levels check, shortest distance check based on the number of edges in the path, like this type of shortest distance. So BFS is important. Another is topological sort. Okay, so topological sort means some questions may be framed based on the dependency based problem. Okay, so some dependency are there, and so like you how you can select the course in this BS program. So this type of problems, some course have the core requisite or prerequisite things, so that you cannot do without completing the other subjects. So this type of situation may be there. So in that case, one version is there, longest path in the DAG. So that one algorithm is there, so that you can prepare, and based on that problem may be framed. So this is also important. So BFS and topological sort in week 4, and week 5 So shortest path. Okay, so shortest path is the one problem, and there are three algorithms discussed. So you can prepare any one of the algorithm which you are comfortable. Okay, so sort you can Dijkstra, Bellman Ford, and that one is Floyd Warshall. So in three algorithm, you can prepare any one algorithm which you are comfortable. So that will perform the task shortest path. So any
Sir,
hmm.
for Dijkstra, if we want to use the heap, then can we
You
use
can
that
use. You
built-in?
can use. You can use. You can use.
Okay, thank you.
Okay, so we are not restricting any library or anything. If you are right now, if you are able to use that heap or any library built in that function which is available in the Python, so if you are able to use right now, same things you can also use the OPPE exam. We are not restricting anything.
Okay, sir.
Like for queues also, right? Any library.
Q you can also use. Okay.
Stack.
Stack you can also use. Otherwise, if some question is required, suppose queue and stack implementation, so maybe sometimes we already given the queue implementation in the question itself. Okay, so you can directly call that.
Okay, sir.
Okay, and so shortest path, one algorithm and MST. Okay, so minimum spanning tree, we have two algorithm discussed, Prince and Kruskal. You can learn any one of the algorithm, both will done your task. So that is two algorithm. At least these four topics you should know. That implementation you should know properly. Problem may be directly based on these algorithms where you need to write the as it is implementation of this algorithm to solve this. Some that maybe different version may be there. So where some you can use this algorithm. Okay, so graph, one question you can expect from this side also. Okay, graph, you can prepare this and.
Okay, sir.
So like if you know on BFS alone, is it enough, or like DFS also you should know? Like both.
I think DFS not required because BFS covered most of the problems. So DFS also can find out the connected component, all these things, but that things you can also do with the BFS. So I think BFS is enough.
Okay, sir. And also in topological sort, we'll get like longest path, like
That
only is required.
yes. So that thing. So both are the actually approx similar version. Some little small change. So simple topological sort and then that longest path in the DAG, that things. Okay, so you can prepare both version of this. Okay, so this is third, and next is one problem, dynamic programming. So that problem will also be based on like single, okay, a simple problem, so not like a two-dimensional table required for that. So that problem also be based on the single array based. So you can store the data of a single array to use the dynamic implementation. So that problem will also be easy, but you should have proper practice for some dynamic programming problems. So another is that one important topic is also there. So heap sort actually, okay, heap sort concept. You should know the concept of heap sort. Okay, so heap sort concept means how we can sort the element with the help of heap sort, and that internally use the concept of heapify. Okay, and we repeat this heapify process during this heap sort. That concept you should know. So maybe some problem, or another is greedy approach based. So this is also a lecture problems. You can see how we can perform some greedy approach. Which is discussed in the big 7, not that AVL3, all this type of implementation we will not ask. So that are the things. I think this is the enough for the preparation for those OPPE exam. So just check the greedy problems which is discussed in the big 7, heap sort implementation in big 6, and this some practice on dynamic programming. Okay. So that are the important topics where you need to focus. So problem
greedy means like week 8 base question also. Like
big
we can expect.
7, big 7. So big 8 is just comes. Some problems are comes under this binary search concept, so divide and conquer things, or merge sort concept. So that you should know, because sorting I'm not including because sort function is directly you can use in the Python. Okay.
Yeah.
So that is already there. So generally not ask any sorting related questions, but you should know implementation that can be used. So like merge sort is divide and conquer, but generally divide and conquer, we generally give this binary search type of problem, not any very new problems like this. That closest point of that closest distance between 2 points. So that type of problem we generally not give, because you have only 2 hours. Okay, two
Yes.
hours and four problems will be there. 25 marks will be assigned for each problem. There is no choice. You have to attempt all. So that will be the pattern. So that solution will be not too much lengthy. So that you can complete in the 2 hour maximum. But practice in this area properly. Just solve some problems on the each topics which I have just discussed. Okay. So that is required.
Sir, and quick select, fast select also there. So algorithm in VK.
Quick select, fast select, yeah, that is there. So that is also okay. That is also a version of for the divide and conquer. That is fine. You can prepare as much as possible if you want. Okay. So that is also improve the complexity. But I have just discussed the important area where you can discuss in the last week. Okay. You can focus. Otherwise,
Okay, sir.
generally at the starting of the course, we just generally suggest that solve all problems by your own. If you have solved all problems of the that assignments and live coding by your own, definitely this exam will be easy for you. But if anyone have not solved any problem, so this exam will be very tough. Okay, so this is the things. Okay, now comes to the OPP mock paper. Okay,
Hello, sir.
yeah, please.
Yeah. In how many questions in OPP there will be any complexity constraint like?
So as I mentioned that if any, so this binary search type of problems. Okay, so maybe one question you can assume a complexity type efficiency checking. Okay.
Okay.
Hmm. Okay. Okay. So comes to the that mock problems. So mock problems are already taken from the previous terms OPP exam. Okay. So that all problems are not new problems. This is already taken directly from the previous terms exam. And as I mentioned earlier, also, so this many problem in the live coding problems are also taken from the previous terms OPP exam. So because of that, we mentioned many times solve these problems, live coding problems. Also, this time live coding problems have the 3 bonus marks. Okay, so you can also complete that before the OPP exam. So that 3 bonus marks will be considered for that.
Sir, for mock,
Hmm?
the 3 bonus marks are for mock, right? This A
No, no,
equal
no, no, no. 3 bonus marks for the live coding problems and 2 bonus marks for the mock. Okay, mock for that quiz, a mock for that OPP, all these mocks.
okay, sir.
Okay, so come still that deadline is already open. I think that is set to the 14th December. If you have not done, you can complete this all live coding problems before that for these marks. Okay, so now comes to the first question. This mock PPA1. So yeah, so I hope you have already tried this. So you can also
Yes, sir.
mention your logic or any change if you are doing, or you can also explain your approach. So first problem is swapping min max. So this is taken, I think, from the initial terms. So that I think first and second term. So you are given two lists A and B and n positive integers each. You can apply the following swap operation to them any number of times. So that swapping operation is like this. We can select any index I, and that index will be 0 to n minus 1, because indexing in the list is only this possible. We can select any index and we can swap the value from A and B. Okay, so it's from the same index. So we have two that list in this example. So this type of swap operation we can perform any number of time in the our list, and our target is here to uh, Okay, write a function which takes these two lists A and B and returns an integer which is the minimum possible value of max of the first list into max of the second list. Okay, you can get after applying this swap operation any number of times. So for this, we have two lists. I hope this question is clear. So in this sample one input,
Yes,
you
sir.
can see 1, 2, 6, 5. First list I'm talking about 1, 2, 6, 5, 1, 2. Okay, this is the first list and second list we have given. If you select without changing, if you select the max of first and max of second, what multiplication you will get? You will get a 6 in the
6
first
into
list
4.
and 4, no, 5. So 5 is the maximum from the second list. Okay, so 6 into 5, that means 30 value we are getting. But if we swap the value of the corresponding index at any number time, we can reduce this. So what is the minimum possible multiplication of the max value from the each after these swapping operations we can achieve? So that is the problem. So,
Yeah.
okay. Anyone want to explain the approach for this? How you did?
Yes, sir. I can try. What I did was I run a loop for the length of the list of
Hmm.
books, since both are of equal length. So I chose the length of first list and
Okay.
swapped the elements whenever there was a bigger element in second list from the first list. Suppose just like for the first index in the first
Mhm,
list the
mhm.
number is 2 and the second list is 4, so we swapped that. Similarly, we checked for all the elements, then we pull out the max and min from the both list.
Okay, so you are saying that we can just compare each index position
Yeah.
and we can take any condition like that. If element of first list is greater than to the second list, we will swap.
Yeah.
Okay, or if any element of the second list is greater than to the first list, we will swap. So we will take any
Yes.
condition. Okay, so in
Yeah.
that way, or at the each index, we will compare and we will just try to shift maximum element at the one list in the each index.
Yeah.
Okay, so in this way, what will happen? The maximum index, maximum element of the corresponding index will come in the one list, and corresponding index, smaller element will come in the second list. So all smaller element will be shifted to the second list. Yeah, so
Yes.
this is correct. So that we can do here. So I'm writing the solution for this. Okay, so function is min max and a comma b. Okay, so after that we will run a loop. So like we can run a loop for I in range. So what is the length of a? Because both lists have the same size. So we will check
Yeah.
the length of a, and inside this loop we will check one condition. Suppose if that a of I, if this is suppose greater than to b of I, and we will swap the element. Okay, so we can take another condition also. So if ai is greater than to bi, then we will swap. So we will just maintain one condition to perform this. So what we will do, we will just write like I say a of I, a comma b of I, and swap. So swap is directly will perform by this. So b of I and a of I, and by this, so swapping is done. After that, simply we will return max of a into max of
Max
b.
of b.
Okay, so this is the solution. Let's run this. Okay, so we are getting the correct, and our private is okay. Fine, fine. If we change this condition, that will also work. Okay, so changed or not? Huh. So I think like this. Still we are getting the all test case pass. Okay, so that means at the every index we are shifting all maximum element in the one list and small element in the another list. In that way we will just reduce our multiplication as the minimum possible. So this is the first problem. This is just a Python type of problem. Here we are not using any algorithms or any logic which we have covered in the PDSA course. This is simple Python problems. Okay.
Yeah.
Okay. Now move to the second. So yeah, this is the linked list based problem. So we have this remove duplicate from the sorted linked list. Okay. So here we have the sorted linked list. So just understand this sorted list, and we have the sample input and duplicate. Okay, 1 second. Remove duplicate from the sorted link. Okay, yeah. So we will just remove because our list contains the duplicate element, maybe or not. So, but the list is sorted. Okay, so this list is sorted. Now we will remove all the elements, but our element order will remain sorted. Okay, as per given. So like this sample input, we have this type of order. So 1, 1, 2, 2, 2, 3, 3, 4, 5, 6, like this. So final output should be come after removing the duplicate element. So that means if we are getting 1, if we are getting second one, we will not consider this. Okay, so that means this element will be deleted. This element will be connected to next unique element. Okay, so 2 will come, and then 2 duplicates are there, so this should be removed from the linked list. So this is actually these elements are connected through the linked list like this. Okay, 1, then 2, then 2, then like this. Okay, 3, 3. Okay, in this way. So here delete operation is required. Delete operation means you have to traverse this complete list, and you have to check the duplicacy during the traversing, and at that time you have to remove the element if any element is repeating, and to check the duplicacy, because this list is already sorted, so all duplicate will come as a adjacent element. So that is the benefits for this. We can directly find out the duplicacy in the continuation. So 1, 2, that means if this is repeated, you have to delete this element, and your connection should be performed directly to this after deleting. Okay, so this is update is required after element. So next should be connected to the next unique element. So after that, these 2 elements should be deleted, and next should be connected to the next unique element, this 3. Okay, so in this way we will modify our linked list. So here actually you don't need to return anything, you need to modify this list. What list we are giving to as an input, you need to modify that list after removing the duplicate element. So your output should come like this: 3, 4, 5, 6. Okay, linked list should be connected in this manner. The same list, we are not creating any new list here. So the same list now should contain these elements, or duplicates should be removed from this. So traversing operation, then delete operation. These 2 operations are required in this implementation. So how we can set this?
Uh,
Yeah, please.
we can take a pointer,
Okay.
a variable that would point towards the head. If the next element is equal to the our pointer, then we would like first we took head equal temp t equals head. If we'll check that if t dot data equals to t dot next dot data, if this condition satisfied, then we'll do t dot next equal t dot next dot next.
Okay.
And if it is not equal, then we'll do t equals to t dot next,
Okay. Okay.
and we'll run this loop until we get none.
Okay, I got your point. So if suppose that I'm just explaining the logic here. So 1, 1, this is connected like this. Okay. So what we will do, so this is suppose head, this is head. So we will set our one variable like temp at this position, temp 1, and temp 2 like this position. Okay. And we will just maintain two pointer for that. Temp1 is now at the previous element, and temp2 will move to the next element after this. Okay, and every time we will compare the value for this data. Okay, so temp1 is pointing to this object because this object contain two things, data as well as the next reference. Okay, so that temp1 contain the reference of object, so we will check the temp1 dot data is equal to temp2 dot data. So in this case, if data is matched, so we will move our temp2 to the next element. Okay, and we will set temp1 dot next equal to temp2 after moving. Okay, so that means our temp1 dot next will be set directly here. So if our data is matched, just do this step. Okay, just set move our temp2 to the next element and set temp1 dot next to equal to temp2. So this connection is now removed. So that element will not consider as a continuation. So after that, check the same thing. Again, if you are getting the same element, do the same thing. But if you are getting the different element, so here you can see temp1 dot data is not equal to temp2 dot data because temp2 is now moving to this. In that case, move your both pointer temp1 and temp2 one position ahead. Okay, so temp2 is will now move to this and temp1 will move to this. So this way we will check the data. If data is matched, we will update our pointer to the next element. If data is not matched, then we will shift both pointer to the next element. So that process will be performed till the last when we will get our temp2 the if our temp2 is reached at the last element. Okay, so the next thing will be the none because this element will contain in the next field equal to none. So when we will get our temp2 equal to none, we will stop the process. Okay, that means our list is completed. At that time, we will just leave our list and our list will be updated. All duplicate will be removed from this. So let's write the logic implementation for this. So here, nothing is given, no prefix, no suffix. Everything is defined as a hidden code or something. So just write the things which is required here. Okay, so you need to write a duplicate function. So remove duplicate. Okay. Remove duplicate. And this is actually getting a parameter head. So head is just a reference of the first node of the list which is given. And inside this, we will perform this tag. So we will set our temp1 equal to head. Okay. And temp2 equal to head dot next. So that is the thing. We are setting temp1 to the first node, temp2 to the second node in the list which is connected. After that, we will run a loop. So while our temp2 does not equal to none. So this condition if this condition is not satisfied, we will repeat our process. Once this condition is not satisfied, we will terminate the things. So inside these things, we have two situations. If our element is equal or not equal. So that we will check at every time. So if temp1 dot data is equal to temp2 dot data. Okay. If this is true, so in that case, what we will do, we will set our temp2 to the next node. Temp2 equal to temp2 dot next. So now our temp2 is moved to the next element. Okay. Then we will update our temp1 dot next. Temp1 dot next equal to temp2. So now this is the updation. Temp2 we have moved to the next, and temp1 dot next is connected to the temp2. Okay, so now middle element will be removed from the chain. So second situation is if, or we will directly write the else situation if our element is not matched. In that case, we will move our both to the next element. Okay, so we will set our temp1 equal to temp2 because temp2 is the next element. Okay, first, and then temp2 equal to temp2 dot next. Okay, so this is the two steps we have done inside the while loop. So this will check continuously and will remove all the element from the list. Okay, and let's check this. Okay, so all test cases are cleared. So you can see we are getting the output list after removing the duplicate elements. So I hope this solution is clear for this problem.
Yes, sir.
Yes, sir.
Okay, fine. Yeah, any query? Others have opened the mic. Okay. So in this way, this is the main important part of the traversing. Okay, so this you have to, if you want to traverse complete list, set your some temp variable to the head and just run a while loop. So this is just a identification to reach at the last node. While temp2 does not equal to none. Sometimes you have to set like temp2 dot next does not equal to none. Okay, so based on the situation, run a while loop because we can not directly reach at the last node if we don't have the tail or something. That okay, so that
Sir, if there are no elements in the list,
sorry.
if there are no elements in the list, then temp1 will also be none, right?
So in that situation, so if temp1 will be head, so head is just a none, and there is no element, so that will also get a none. So that loop will actually not run. Okay, your code will not affect anything, so that your list will remain as it is. Okay.
No, sir, in that case, head.next will not work.
Okay, so that case, okay, we have to check the question statement. So it is
Edge
mentioned that you are given a non-empty linked list.
Okay, sir.
Then you have to validate this. What you can do if it is not given, you can validate this. You can simply check first if head is equal to none or not. Okay, if that is the case, if head is not equal to none, then do this task. So you can validate these things. Okay, just check the condition if this is none or not, head is none or not, then do the task. Here it is already mentioned that this is non-empty list. That means that will contain some element. Okay, so this is the first linked list based problem. So here you can see how we have updated, how we have deleted the element. So this delete operation is done in this. Okay, next move to the PPA3. Merge two sorted linked list. So this is again sorted linked list based question. But here there is one more concept is a test, that is merge two sorted list. I hope you know, and that is already used in the merge sort algorithm.
Yes,
If
sir.
you have two sorted list, how you can merge that two sorted list into a one sorted list. So I hope you know the concept of this merging. So that is the concept of merge sort. So which is merge, we generally call this function, and we have suppose two sorted list like this, 2, 5, 6, and 10, and another sorted list is like this, 1, 3, 4, 10, like this. Okay, now we want to get a one final sorted because both are the sorted list. This is the input, and we want to get uh, a final sorted list after merging this. So how we can do, we can set some index pointer, so that is 0, 1, 2, 3. This is, I'm talking about the list. So 0, 1, 2, 3, this is the index. Okay, so we can set some pointer I to this and j to this array. Okay, suppose this is a and this is b. Then we can check ai is equal, which one is the smaller. Okay, so which one is the smaller, we will move to the final sorted list. So that we will take one final list, suppose this is c, and we will append the element directly. So if ai is less than to the bi, then move ai to the c, else move bi to the c. Just repeat this process, and after repeating the process, which element is moving to the c, just move the index to the next element of that list. Okay, so this is the approach only for this. So just check here, AI is less than to BI, no, else. Okay, so else part is, this one is true, so this one will be moved, and just this J will be moved to the next position. Okay, again we will check the same thing. AI is less than BJ. Okay, so here, yeah, this is correct. Now 2 will be moved. Okay, and I will be shifted to the next position. And same way, here AI is less than to the BJ, no, else part will done, and we will move 3. Okay, and this J will be shift to the next position. So here again, now this 4 is smaller, so 4 will move, and again J will shift. Now 5 is smaller, so 5 will move, I will be shifted, and then 6, again I will be shifted. And in this case, we are checking this AI is less than BJ, no, else part. Okay, else part, then we will move this J, so this will move, and now this is completed. If any list is completed first, the remaining all element of the another list we will directly move to the uh, final sorted list. Okay, so only one element is there, so 10. If any other element is also there, it's like 20, so that will also be moved. 20. Sorry. So in this way, we can merge two sorted lists. Same concept we can perform with the linked list. Now that linked list concept is simple, head, and that is head one, suppose, and this is connected like this. Okay, and 1, 5, 6, and suppose 10, and then head 2 is there, that is also connected in the same nature, like 3, 6, 7, 9, like this. Okay, so here also we can set some variable like temp1 to this and temp2 to this. Now we will simply compare temp1 dot data is less than equal to temp2 dot data, and if this is condition is 2, we will just move the temp1 element to the final sorted list. Okay, so we will create another list, head 3, and we will create a new list. So okay, so we can create a new list like this. So one node will be created and this data will be moved 1. So that will insert, actually every time we will insert a new data. So every time a new element will be inserted, so temp will be moved to the next position. Okay, now 3 is smaller, so 3 new node will be created, 3 will insert here, then this temp2 will be moved to this position. So in this way we can do the merging of two sorted lists. So then 5 will come, then okay, then 6 will come, and again 6 will come for the another list, then 7 will come. So in this way new list will be created. Or what we can do, we can suppose we have some more element after this, so like this list have another 3 element. Okay, like 20, 30, and 40. So during the comparison, 9 is now shifted here, so after 7 and then 9. Okay, so now this is done, this is still remaining complete. So what we can do, we can directly pass the address of this element. This is already, this part is already connected to reduce our time. What we can do at the last, if any list is remaining, we can directly append that list. Okay, so we can store the address of this list of this 10 element to this our 9 next field. So what will happen, so that part is already connected. Okay, so our traversing will also be happen like this. Okay, we will reach at this position, and after that we will got all these previous elements. Or you can also create a new elements, new list node for the remaining element also. So this is the approach. The same merge approach we can apply with the merge, this linked list merge concept, and we can do these things.
Sir,
Huh.
sir, have you discussed about in linked list traversal?
Linked list diversion.
Traversal, sir.
So
Traverse.
previous question we have, I think, discussed. So this question will also cover the traversal. So
Okay, sir.
traversal is the by default operation you should know to perform any operation. Suppose if you are deleting the last element, you have to traverse the list. Okay. So here previous question we have discussed. So that was the remove duplicate element in the list. So we have done this traversing using the while loop.
Okay, sir. So I joined 5 minutes ago only.
Okay, okay. So same things we have to do here. We have to also traverse both lists to compare the element, and then we have to create a new list to return the output. Okay. So according to the question, we have head one and head two are the reference of first node of the two sorted list. Function should return the reference of the first node of the merge sorted linked list. Okay, so that means one new list reference we have to create here. So okay, to for the solution this. So we will just write a definition so that we have the name of function is that merge sorted.
Sir, could you please zoom in?
More zoom. Okay, it's
I'm
fine.
not I'm not from this side. Could you please zoom in the question?
I think there is no option to zoom the question and both at the same time. Yeah, this is the question.
Okay, sir.
Okay. So here the question is we are getting two sorted lists in the link list in the input. We have to merge these two sorted link lists and we will be convert that into a one merge sorted link list. Okay, and we have to return that. We have to return the first node reference of the sorted merge list.
Okay, sir.
So this is the required. So sorted list and then head one and head two. Head one comma head two. So this is the required parameter we have in the function, and after that we can set our two pointers. So temp one equal to head one and temp two temp two equal to head two. Okay, this is the two things, and one we will create head equal to head three, or we can give any name. So like head three equal to initially none. We can set this. Okay, so what is this? So we have set our two variables to the given list as a first node on the first node. But head three we have created as a empty list, empty link list. So we will insert all nodes in this list head three. Okay. So now this is the first thing. Okay. So temp three. Yeah. So to make simple this, so what we have to do every time actually, if we want to insert a new node, okay, in the final this head three, so we have to insert at the end. Okay, so what we can do, we can take one additional pointer, so we can give the name like as a that temp uh, 3. So temp 3 is will work as a tail for the our this list. Okay, so what how we will this will be helpful. We can directly insert our new element into at the end with the help of this temp 3. So temp 3 will contain the reference of last node after inserting in the final output list. So we can directly append our element. Otherwise, what we have to do, we have to traverse every time from the first node to reach at the last node, and then we have to insert. Okay, so as you know, every time we found the smaller element corresponding when we are comparing, and we are adding this element into this list at the end. So we will maintain one some tail pointer type of things, so that will contain the address of last node, and that will helpful for the insertion at the last position in this output list. Okay, so that is just a for some just saving some our time. So temp 3 is we will set this also as a none initially, and after that we will run a while loop. So while loop.
Sir, I joined some 5-10 minutes ago. I just
Oh.
wanted to know when we are writing head 3 is equal to none, we don't have to create a node or something.
No, we are just creating a variable that will contain the reference of the output list, first node of the output list. Okay.
Y-
Initially,
yes.
this is empty, but we will add node one by one in this.
Okay, but we haven't created a node.
So that we will create because that node class is
Okay.
already there. So you can see uh, in this class node is there. Okay.
Yes, but we haven't created it yet, no?
We haven't created, we will call this only. This
Okay.
structure is
Got
already there in the code, which is not given as a visible code, but it is already there.
Okay.
So we can call this node, and this have two field data, and next we will assign our value into this. Okay. So yeah. So while we will set our temp one, because we don't know what is the size of the both list, because there is a chance size may be different. This is not given in the question. Both lists have the same size. So we have to check our both pointer. If temp one does not equal to none, and okay, temp 2 does not equal to none. So during the comparison process, if these two conditions are satisfied, that means we have elements in the both list to compare. Okay, temp 1 is not reached to the none, temp 2 is also not reached to the none. So this is the traversing for the both list. So we are just we are just traversing both list, head 1 and head 2, and we will compare the element. Now to compare the element, we will take the condition if temp 1 dot data, okay, temp 1 dot data is less than to the temp 2 dot data. Okay, if this condition is true, so what will be the case? Because first time we are just taking this as a head 3 as a none empty list. So this is the first case. Once the one node will be added into this, in that case uh, we will set our temp 3 also to the last node, and we can directly add from that node next field. But the first time we have to set our head 3 to the first node. Okay, when we are adding that first node to the list, so we have to set our head 3 equal to that node. So what we can do, here you can create a node as well as you can also directly add the node which is already given in the list. So that okay, you can create the node. So first thing we will check if our node is adding first time in the list or not. So we will check this condition because this is the repeated condition. This will come continuously. So that we have to check if head is equal to none. Okay, so that we are checking if our head is still none, not head, sorry, 3, head 3. Then what we will do, we will set our head 3 equal to the that node. Okay, so here okay, one second. Okay, let's create the node. That new node equal to node. We have created the node, and then okay, if this condition is set true, new node equal to this, and we have to pass the data also. So this is the required parameter. Okay, so now if temp1 dot data is less than to the temp2 dot data, so what we have done, we have created a new node, and that node is now created with this data temp1 dot data. Now connection. So connection we will do with this new node, temp head equal to new node, and after that, so this is the first condition, and we will also set our temp3 that is working as a the tail that will always contain the reference of last node. So here this time head 3 only. Okay, here again we missed head 3. So this is as a first. Else case. So now this else part. So in the else case, we will always add the element, add the node at the last. So the last reference is stored inside this temp3. So what we will do, we will directly write here. So temp 3 dot next. Okay. equal to new node. Okay, and we will set up a temp3 equal to that temp3 dot next. So now this is the situation, and because we are moving our temp1 data, okay, that means first list data, so that we have to move our pointer to the next point. So that is okay, this is coming inside the if. Okay, so this is under the if. Okay, temp1 equal to temp1 next. So this is the one thing. So if this condition is true, this element is now adding into the final output list or appending at the end, and we are just moving the pointer of temp1 to the next node. Okay, now the same situation will become as a else part for this condition else. Okay, so now we have written the same thing, so not this part will not come. Now again, this time temp2 data will be, new node will be created with temp2 data, and I think head3 is equal to none, head3 equal to new node. This is fine, this is also fine, and only this pointer will be moved temp2 dot temp2 dot next. Okay, so you can see now this condition is done. So now if we have the element in the both linked list, so this part will actually compare the each element and will add to the final merge list. But suppose one list is completed and one list have some remaining element, so that part still we need to do. So that part will come after this while loop. Okay, so if this condition is suppose break, but still some elements are remaining in the any one of the list, so we have to check this condition here. So for this we will check if temp1, okay, temp1 does not equal to none. This, so that means if temp1 does not equal to none, that means temp2 reached at the none position. So that means temp1 the first list have some remaining element. So in this case what we will do, we will directly set our temp3 dot next to the temp1 point, temp1. Okay, we have directly connected to the remaining list if anything is remaining. Same for the another. If temp2 dot does not equal to none. So in this case, we'll directly set our temp2. This.
So like you are only just changing the reference.
We are directly connecting the remaining list to the our output list after that. Okay, so that means what we are doing. So just I'm telling you, suppose we have this head1, head1, and this contain a element like 1, then 2, then 3. I'm just writing randomly. Okay, 4, then 5, then 6, like this. Okay, and another head2 contain the reference of like 2, then 4, then 6, then 7, then 8, then 9, then 10. Okay, so output list, what will happen? So this one output list will be create like this: 1, then 2, then another 2, then 3, then 4, then 4, then 5, then 6, and another 6. So after this 6, you can see what we can do. If suppose this list is now completed, okay, but this still have the remaining chain. So at the next of this previous 6, what we will do, we will directly connect the reference of here, this point, the previous list. Okay, we will directly connect this reference here. So remaining part is already connected here. So in our output list, connection will work like this, and after that here, and this remaining element will be traversed. So now you can see this is now a merge sorted list. So we have directly put here this part directly we are putting at this place at the next. Okay, And we are so temp1 is now pointing to this list, temp2 is moving to this list, and every time we are checking if temp1 does not equal to none, that means this list is still have some remaining element. Temp2 does not equal to none, so that means this list is still remaining the element. So we are directly connecting in the last line, okay, by this line. Okay, if any
So
list,
I have a question.
yes,
Here, we're sort of duplicating nodes, right? The remaining part of the nodes we're using to append to the new list, right? But the starting ones, the one that we compared, they are also there and they are also in the new list. So isn't it possible with the existing lists, list 1 and 2, can't we take that nodes and reference them to each other?
you can also do that.
Is that possible?
It is possible. Without creating a new node, you can simply direct connect that node temp1. Yeah. Okay.
Yes, sir, but that may change the original order of the two
so
given
that
lists, right?
actually, okay, so that what we are doing with the original list, we are not doing anything. Okay, our output is required to a merge sorted list, so that will only be traversed by our code in the later.
Okay.
So if we have distorted the original input list and that element is not used after that, that we can do here. Okay, so we have created a new node here, totally said that is not touching the original list, that is not disturbing, but yeah, we can do that also. So in that case, this is not required. You can directly set here temp1. Okay, temp1, and there is no required for new node. So same things we can do everywhere. So that is also possible. Okay, I think we missed something. Because we have not returned the head ID. Like this. Return. Okay, now we got the output. So you can try with this simple temp also. Temp will just put this temp1 here. So I think that we can do also. Okay, here in this case temp1. Okay, temp1 here, this is temp2. This is the only change. Okay, so that is also passing the test case. So nothing. Okay, so that you can also do. We are using the now same node.
Oh, so that means you've just linked them within the original list. You have just linked them.
Yes, yes. Okay, we are not creating any new node now.
Okay. Which one is better?
I think this is also fine for the space purpose, because when we are creating this new node, it is taking more space.
Yes.
But if it is not affecting our output or anything, so that is also efficient for.
Unless you need the original lists.
If original list is required, then in that case maybe some disturbance will be there.
If original lists are required, then even the last part of it, then we should not link
that we have to also perform by the while loop then.
Yeah.
Okay, you have to run a while loop till the reaching to the none node. Every time you have to read the node and create a node and append that like this. Okay.
So we can also do it like this itself, even without creating new node. Right?
So that I have already done. So without creating a new node, that is all this code is there. Okay, without creating a new node. If you want to create a new node for every part, here actually this part is not created new, this part when we are appending. So for this part, you can also create a new node for the every element. In that case, you have to run while loop. Okay, for this condition, while temp1 does not equal to none, just create a new node and append the value of that node and move your temp1 to the next node. Okay, same thing for temp2. So that you have to done. So in that case, totally complete new list will be created with the new nodes. Okay, so I hope you're getting my point here. Let me just tell that also. So that is this one. So this. So this is the situation. And for this case, we will use this while loop. Okay, while this condition is true, so we will create a new node. So like this, temp1 does not equal to none. So we will use this one here. Okay, and we will set our temp3.next equal to new node. And we will set our temp3 equal to temp.next. And we will move our temp1 equal to temp1.next. Okay, so this is done inside the while loop. Same things we will do with the next case also. So while now this is 2, and I think all this fine. So temp2 this. Okay, so where's this also? All pass. Okay, so now all nodes are creating new. You're not using the original list in any output list. Okay, so all these things are the traversing. So traversing part is by default you have to use in your any code.
Sir, so the code we wrote earlier will also work, right?
Ha,
That
will
was not
also work.
wrong.
Yeah, that is also fine.
Okay.
Like without creating new node.
Without creating new node, that is also work, because we are not using the original list anywhere after that. Here, this is totally new space we have created, totally new list we have created. Okay, without using any previous that original node. So this is another version. Okay, so I hope this is clear. And move to the next.
Excuse me, sir. Can you show the code? Yes,
Okay.
sir.
Yeah, this. Is this fine, or shall I zoom more?
Yeah, a little bit bigger.
Now it is not coming in the one screen. You can just tell me that to scroll up, scroll down.
Yeah, can you go down, sir?
Okay.
Yes.
Done. Can I move to the next?
Okay, sir.
Yes, sir.
Okay. Okay. So now this problem is based on that binary search concept, as I mentioned. That you can see here. This is mentioned also. Okay, log n time. This solution should be work in the log n time. So in this type of test case, you can see some input are small. Okay, so this length is very small. So that will pass by the linear solution also for this. So this you can see here, this is the large input. Second test case is the large input, maybe 28,000. This is the output, but it may have the more element. So like this something 10,000. Okay, expected output is this. Okay, this is asking the peak value. You can see this is the last test case. Question is asking to the a list that takes a list input, return the index of, okay, index of peak element. For example, peak unimodal that takes a list as a input and returns the index of peak. Okay, but then in this case, okay, yeah. So yeah, that is actually peak that unimodal type of list. So that because of that last index is actually last value is smaller. Because of that I confused. Huh. So what is the nature of that input is that list is increasing first, then decreasing. If you can remember, we have discussed this type of problem in the live coding session. So this list is increasing, then decreasing. And question is, what is the index of the max element? And all elements are unique in this. Okay. So this is the input type, and that means this list is not exact sorted, but still have some pattern. Okay. So that means pattern is just like as a increasing and then decreasing. So still we can use the binary search concept with have some with the help of some conditions. So that will provide the solution in the log n time. Otherwise, the linear so linear approach can also you can write here. So suppose if I write a linear solution for this, so that is so function name is function is peak unimodal. Okay, unimodal. Okay, and that is taking a list only. So that is list. So that list name can give a. You can take any name. Okay, so inside this function, what we can find out, we can check the max. Okay, so because the peak element will be the max element also. Okay, but here we need to return a that index of that. So return. Suppose if I like that as a return max of a. Okay, so that will return a maximum element. So let's run this and see what is the behavior of our code. So okay, now you can see we are getting the some output for this first input. Okay, and second test case we are not getting the output, we are getting some message. So that message is your code execution time is this, but expected time is this. Okay, so you can see your code execution time is much higher than the required time. And for index, so that we can find it like as a dot index, I think in the Python. So you can see first test case is passed 5, but other test cases are failed. So same things will be happen with the private test case, because here time is not met, because this is a type a linear approach. Because if we are calling this max function from a, so this will actually apply a linear search in this to find out a maximum. After that we are just getting the index. So this is just a constant. This is also not a constant, because finding the index of the one element in the list, that will also figure out a searching for that element and then will return index. So both are the linear type of operation. Because of that, this become a order of n operation. So how we can figure out this solution in the log n time? So let's take some sample. Okay, can anyone tell me the approach?
Yes, sir. You can, like, first of all go to the mid value.
Okay, 2, 3, 4, 21. Sorry, 21 is closure. 21, then 43, 52, 51, and 18, 11, 6, 5, 1. So indexing, I am just writing here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Yeah, what you are saying, just check the middle element. So we can just use like as a 0 plus 12 and divided by 2. so that we will get
Six.
6 index. So 6 index is this. Yeah. Then what we will do?
Now we have to check whether this is bigger than both mid minus 1 and mid plus 1.
Okay, okay. Yeah, correct. So how we can, so first thing, what is the nature of this input list is like this. Okay, so this is increasing, then decreasing. Okay, this way. And this is the position where the peak element is there. Okay. So every time what we will do, so this is the 0 index, this is the n minus 1 index, and in between that point come anywhere. This next peak element come at any place, because we are not saying that this peak element will always come the middle element. So the list nature will like also this. So 1, 2, 3, and not like this. So 1, suppose 5, 10, 14, and then like 3. Okay. So in this case, now this is increasing, then decreasing. So like this. So this position is coming at this place, peak element. So we have to figure out that every time we will find out a middle element. Okay, so we will check the middle element position. So to validate our middle element is the peak element. So that means, suppose if you are getting this point correctly, so you can see on the left side and right side, both are less value. Suppose the previous value at this point and this value is this point. So you will get the situation that suppose this am will be greater than to the am minus 1, this, and also greater than to the am plus 1. So if this type of situation is coming, so that means that is the peak element, because this situation will come only with the one position, that is a peak situation. Okay, so you can value after checking the middle element, you can compare your that all adjacent element and then return the output if this is true. Otherwise, if you are just pointing to like this slope or like this slope, you will always found that one element will be lesser but one element is greater. Okay, so suppose this is m and m minus m plus 1 this side. Okay, and m minus 1. So m minus 1 will be greater but m plus 1 be smaller. So in this case, which side actually our data is increasing? Okay, so that means you can discard this part. You can discard this part because our elements are increasing in this direction. So this part you can completely remove and check the remaining part like this. So that will be the half. And same situation if you are coming at this this slope, and this is the m point, middle point, and you are checking m minus 1 and this side m plus 1. So your elements are increasing like this. Okay, m minus 1 will be the smaller, then that bigger, then next bigger element. Okay, so elements are increasing this side. So peak element will come in this direction. So you can discard this part. So in this way, you can discard half of the part and just check the next part at every situation. So this logic we have to write in the same scenario of the binary search concept. So inside this peak model algorithm, so what we can do, we can just set our low and high. So low equal to 0 and high equal to n minus 1. Okay, not n, ln of a minus 1. Okay, this is the last index. Now we will run a loop. So while, and we can set this as a true. Okay, we will run this loop, and at any point we found, because definitely this type of list, one peak element will be there. Okay, so we will return our output once we will find out our output. That will directly break this loop. So if this is true, while this is true, then we will check our mid element. So mid position, so mid equal to, and what will be the mid, so that we can directly calculate. So low plus high and divided by 2. Float division we are taking because that will not return that float value. So this is the first thing. Now we will check our condition. So if mid, not mid, sorry, a and mid, if this element is greater than a of mid minus 1, and this is also greater than to a of mid plus 1. Okay, this situation is the output, and return your things. Return, because we need to return a index. Okay, so mid, we will return a mid. If we want to return a value, so return a mid. So that is the output situation. Else part, else if, okay, no, elif. Now the situation is just like a increasing type of situation. So in that case, suppose if we are getting this, all are actually increasing. So this is okay, and this is also increasing. Okay. So that means elements are increasing in this direction. So that means we can discard our previous half before the mid position. So to discard the before position, we have to set our low to mid position, mid. Okay.
Or mid plus 1 also.
Okay, mid plus 1. Let me check that also. No, I think that will create maybe problem. Mid. Give me a second. Plus 1. Why this is coming? Else. In else part, so one condition is remaining. If this is not true, then else part we will set our high to mid minus 1. But I think that in that case, one situation will be there. So let's, I think that is done. All done.
Do we need a base case?
Base case, no, I think that will work. Because we have the situation like this. This is the mid peak element situation. We are returning the answer. Array situation, we are checking our elements are increasing in this direction. So that is one situation. We are setting our low to mid plus 1. That means we are discarding first half. If this is not the case, so that means our elements will be decreasing. Okay, in the second half type. So in that case, we are discarding the second half. Okay, high equal to mid minus 1. So that while loop will run. It always it will be divided into the half. Once we will get our output, that return will be happen, and that will stop the loop also. So let's run this. Okay, it is working. And let's submit test, private test case also. Okay, yeah, it is working. So you can see now all test case pass without giving any time efficiency issue, because this code is the same log n complexity code. That is working fine. Okay, so we are using the all approach. So this condition we have taken as if peak element in if we are so these are the three situations we will get. So either we will our mid element will come as a peak element, or the left side or right side. So all we have covered in this solution. Okay, so this is the one solution for the this binary search based concept. You can just practice on some more problems, like suppose if you have one missing elements. Suppose if you have the element from like 1 to n. Okay, so 1 to continuously 1 2 3 4 5 6 continuously n, and in between one element is missing. So that you can identify it with the help of binary search. So that one problem is there. And if suppose if you have duplicate elements, that every element is duplicate. Like the duplicate means two elements are repeating, but only one element is exists as a like single time, and list is sorted. So in this type of problem, you can use this binary search concept. Some rotated list, that is also discussed in the lecture. Rotated list, you can use the binary search concept. So some problems are already covered in the assignments. You can practice on that, or you can also search what type of problems can be solved with the help of binary search. So that is one. Uh, 1, 2, 3, 4, 5. 5 is not there.
No, sir.
Oh, we missed. 1 second. Give me a 2 minute. That problem I think we missed to publish. Okay. Okay, now this is okay, but some issue is there. Just give me a 2 minute. Okay, that one problem we missed actually to publish. Now it is published. Problem number 5. So yeah, this problem is based on the graph, one graph concept, and so you can see. Uh, Actually, this problem is also taken from the initial terms. So that is some competitive problem type of problems. Level is high, but this is not too much high. But if you can think, you can also figure out the logic. So what we have actually in this problem, a traveler made a travel plan which start from city S. Due to time limitation, he decided to choose a shortest circular route that returns to the starting city S without using any road twice in the route. The route need not visit all city. So that overall we need to find out a shortest circular route. So I think graph is there. So otherwise I'll discuss it. So shortest circular route that accepted this adjacency list of the graph, and that contain n city level from this, and we figure out that what is the cost for the shortest circular route in the from city S. So what is the meaning of this? We have some graph like this. Suppose we have one S node, and after that we are just moving like this A, and then B we have, and we have another node also D, and suppose this thing, this is coming like so weights are also given like 1 yeah 3 and 2. Suppose this is direct, not directed. Let me take directed. So what is given in the question statement? Undirected. Okay. So here some weights will be given like this 2, and this is suppose 5 3 1. So one starting node is given. Now you need to find out a shortest circular route without repeating any edge in the path. Okay. So shortest circular, what is the circular route means? it can be start like this: S, A, then B, okay, and this is undirected, okay, no arrow there, and then a B to S again. Okay, so this is one possible circular path, okay, without repeating any edge again. So what is the cost for this is 1 plus 2 plus 3. Okay, another is like this: S to C, then D, then E, and then S. So what is the cost for this is 2 plus 5 plus 3 plus 1. Okay, this is the cost. So this is 6 and this is 7, 11. Okay, another is also possible like this: S to B, then to C, and to that S. Okay, that is another possibility. So then same 3 plus 1 plus 2. What is the cost for this is also 6. So in this way, what are the possible shortest route we have? So we need to figure out that which one contain the minimum shortest path weight. Okay, so we need to figure out this. Now here in the helping function, because this problem requires some additional approach, so here some code is also given in the solution. So that is actually digestion algorithm. You can see. So this question is not directly based on the digestion algorithm. So based means it will not return a result only with using this digestion algorithm. You have to apply some more logic with the help of this. So this type of questions, some helper function will be provided to you. You can use that, and you can write your logic after that. Okay. So how we can solve this? Any approach, anyone? How we can get the shortest circular path distance? Any logic, anyone? This type of
We usually put the source code as 0 and visited. So in this, if we don't mark the source code as visited, would that help?
Okay, but it will create a problem of the digestion algorithm, because digestion algorithm always pick the smallest element, okay, smallest weight element. Then you have to modify complete digestion algorithm in this case.
Okay, which we can't because it's a given.
Already given. So you are just updating, like you are setting this as a 0, and then you are updating the distance. You are picking the next smallest distance, and like this. But if you are not updating, if you are not setting this as a mark visited, then always this node will be picked by the rest. Okay. Another possibility. One thing you can think about, if we are just moving through any path, so every time you will always move through the adjacent of this S. Okay, so what are the adjacent possible? So S, how many adjacents are there directly connected? So that is one A, another is B, and another is C, another is E. Okay, these are the nodes which are directly connected to this. Okay, so that means you can, if you are moving from S to A, then return path cannot be come through the A. Okay, that path will come through the another node, another adjacent. Okay, so that means that path will be come to either B or either C or E if you are moving to this path. Okay, so same things if you are moving from S to B, and then B to you have to come through the another adjacent on this S. So here you can think a little bit about so for this S, how many adjacent nodes are connected? B and C and E. Okay, if you apply the shortest path on this node, okay, and just remove this edge, just for the from the graph, remove this edge from the graph, and because the remaining graph is already connected, or we have already removed this edge. Now apply the digestion algorithm on this A, and find out the distance for S. Okay, so that means we are applying the shortest path from A to S using the raster. We are getting this information. Okay, so A to S. What is the shortest path? So we will get one shortest path from A to S. Shortest that distance will become by applying this, and then we will add. Suppose this is a E1 and this is E2, this is E3, and this is E4, and then plus. So this is this is suppose D1 distance. We are getting A to S. We are getting D1 distance, and after getting this shortest distance, because this is the shortest path returning by the Dirichlet algorithm, and we will add D1 plus E1, because that is we have removed. To make this as a circular path, we have to connect this also in the final distance. So D1 is now A to S shortest distance, so that will come, so that path will become through the another adjacent. But later, to make circular, we will also add this in the final distance. Same things we will apply to from the B. Okay, now we will apply the Dirichlet algorithm from B, and destination will be S. At that case, we will remove this edge only. Okay, so that E1 will remain in the graph, but E2 we will move. So you will get some shortest distance from B to S. So that suppose is D2, and to make final distance of the circular path, we will add as a D2 plus E2. That is the one. Same things we will repeat with this C. So C to S, suppose this is D3, and we will add later D3 plus E3. Okay, same for from E. So E to S, and that is suppose D4, and D4 plus E4. Now we got these 4, and we will find out the minimum among all these. Okay, minimum among all these 4 cases. So this is the only possible case, because if you are going through this A, so you will come through any another adjacent. Okay, so that is the one possible circular. If you are moving through the B, that will be the another possible circular. That if you are moving through C, that is the one. That if you are moving through E, that is another one. So this is the 4 possible situation where from you can move, and you will get a circular path. So that we will figure out by calling the Dirichlet algorithm on A, then B, then C, then E, after removing the direct edge from S. And we will get this 4 distance, and we will return a minimum among all these 4. So that will be the shortest circular. I hope you are getting this point, this approach.
Yes.
Okay. So, but to call, because Dirichlet algorithm we have already available, what we have to do, we have to update our graph at the every call. We have to call our Dirichlet algorithm for each adjacent, and before calling this function, we have to remove this edge E1, and then we will finally get the output. For the next adjacent, we will add that E1 again. Okay, for next case, we will remove E2 only, and then we will find out the shortest distance, and then we will add E2 in the total distance. Again, we will append this, add this into the original graph. So this things, so that means we have to update the graph. We have to remove one edge, then later we have to add this edge for the next part. So this part we have to done. Otherwise, this problem is simply a continuous call of the Dirichlet algorithm, and that will return all possible circular path distance, and we will return a minimum among all. So that is the approach for this. So how we can write the solution for this? So that is the function. Okay, so WL. Okay, so this is the original list we have. You can give any another name also. Suppose W list. Okay, because W list is also used here. That is fine. So we can take any name. The original list we have this W list. Okay. Then what we will do? We will maintain one list, because we will get a multiple shortest path. Okay, so shortest path weight actually. because multiple sort a circular route will contain the multiple weight. So we will maintain a path list. So path weight equal to empty list. We will append all the solution in this list, and after that we will return a minimum on this. Next thing is all the adjacent. So what are the all adjacents we have? So that we will figure out in this list of the source. So that is the one. And to figure out the source, what are the adjacent of the source we have? So we will run a loop. So for that node in that w list, and because this is a adjacency list, so source we have this s, and
Key.
so this is the key, and corresponding value will be represented as a connected, direct connected vertices. So that's are the adjacent. So we will just copy all this adjacent in our ADJ list. Okay, dot append node. Okay. Node or vertices, you can give any name. Now our all adjacents are now added in this adjacency list of this source. Now we will apply our approach, that approach which we have discussed. Now we will apply for the each adjacent. So for each adjacent, or you can give any name like this, AD node, okay, adjacent node, okay, in ADJ list, okay, adjacent list. For each node, adjacent node in this list, we will perform this. So what we will do, we will simply copy the original list, or you can also use the original list, but you have to remove all the information regarding that edge which you are removing here. Okay, source 2, because we are selecting one adjacent, so we have to remove all the information as to AD node or AD node to S, because two entry will be there in the adjacency list for this interactive graph. One from S to ADJ node, that adjacent node, and reverse also, ADJ node to S. So two information will be there in the adjacency list. We have to remove both entry. So what we can do, we can make the copy for this, or we can simply perform the task from the main list also. So that will actually w list dot remove, that we can do remove. And what we have to remove, we have to remove a key for this. Okay, so that key we will remove, ADJ node, AD node. Okay, yeah, that is the one thing. Another is okay, another thing is remove ADJ node keys now removed, and another node that is AD node. Okay, w list. And what will be there? This dot remove AD node. Okay, so first understand that what type of entry will be there. Suppose this source index and destination is there, so that source adjacent to that source. So adjacent we have removed directly here. No. So that, okay, one as we have to remove. So I think we missed here. S and AD node to S. So that because first value in the, okay, so first value in the value list is actually tuple. Tuple first index is representing a destination. S to remove. S This is the thing, removing key. No, what this is 0. And we have to remove the complete list. Something is wrong. Okay, so let's understand this. So like we have the data like this W list, and we have the source, and suppose this source has the key, and that contain a, so that tuples. So in the tuple, every tuples have the destination. So that is actually destination index and distance. So destination index and distance, like the source index to this one. So suppose this ADJ first adjacent, if we are talking about, that comes here. So ADJ, comma, some distance is there. The distance is there. Okay, so that information, so that we have some more information. And reverse side, we have this ADJ and ADJ, and then
The source.
so same things for the source and distance. Okay. So to remove
We'll
this,
have to move through the list to find that adjacent node.
so S to ADJ and ADJ to S, both information is there. So to remove this W list, on this we have to remove S dot remove. ADJ. S, this thing. Adjacent, okay. It's here and to this ADJ. Suppose if a condition is like this, S to A, we have some distance 1. So that is okay. Is this double? So in dictionary we have to distance.
By doing this, we're removing the tuple agency
we have to
node from
Uh-huh.
the list in the key S.
Okay. So what we can do, so that S, because this is now pointing to a complete list, remove adjacent AD node,
Which is
and
a tuple.
that will contain some value. So
Which we have
ADJ
to put
node is
in
the
path
first.
weight.
So what will be the, we'll get the path weight. Okay, so that will be distance. Yes. Distance, we have to figure out ADJ node, what is the distance of this. So that I think we can figure out. This and no.
AD node here refers to a tuple, right?
So that AD node is the first adjacent actually we are talking.
But it's a tuple, right? With the vertex and the
Okay. Yeah,
distance.
got it. Yeah, this is not tuple, so that is simply AD node. Okay, yeah, that will work. Yeah, fine. Okay.
But don't we have to also add the AD node 0 to that path weight?
No, this side is fine now. So source to AD node is removed by this.
Yes, this is fine. But don't we have to add this edge to the path weight?
No, that is not required because we will call dasta on the adjacent node. But later we will
We
add
need to
this.
add that. We
We
need
add
to add
this.
the weight.
Okay, that we have to read the weight also, correct. And also we can save this in some place. So like this edge, okay, and directly AD node. Because we will append this later also again in the original graph. So suppose this here we are storing, so that AD edge second value will be the distance for this. So that is fine. But from the second side removal will be actually AD node 0. So okay, now we want to remove the complete information of the as a source. So that is actually a first value of this edge. Okay, AD node first index is representing a vertex. That vertex that we will directly remove here. Okay, so that is okay from this and okay, source information. Okay, yeah. So that first value tuple is will be the source. This is capital S, and second will be the weight. So that weight will be the same for this. We can write the weight like this: H and the second value, one index value. Yeah, now this will work because what we have done, we have removed the S. This is also capital S. S. Okay. So yeah, source from source list we are removing this complete tuple. So that is now a removed from S to this side of information, and from adjacent node, this is now we are using as a key. What is that adjacent node we have? So that key is now representing the first value of the tuple. So from that key we will remove this tuple. So that tuple will be the S comma weight, same weight from that which is connecting.
This will be removed or removed?
This will be removed. Okay. So now this is the two things we have done. Now we will
This
call
would
out
be for a undirected one, right?
undirected because graph information is undirected. This is the undirected graph. Now we will call our digest algorithm. So that will return directly. So what is the algorithm? So you can see this function we will directly copy. And that will return a distance. Complete this distance is just a complete dictionary. So for that dictionary, we are passing this ADJ. Okay, so ADJ node as a source node here. So that we will pass in this here, and inside this AD node. So that distance list will be written from distance. So we will get a distance to source from that node. Okay, so that will provide the what is the structure of the one sec, let me check that also. So distance is a dictionary, and distance will provide the shortest distance. We call this will return distance, and distance is from AD node to S. That is fine, I think. Okay, D. So that is fine. Now we got the distance. So for this distance, we will add in our that edge distance. So that we will append in the path. So that path is just our path weight. So path weight and path weight dot append and D plus. So D plus and that edge. So edge and second value. So okay, so one index. So now this is the total circular path weight we got for the first. Okay, that is appended into the list. Now we have to append our removed edge again to the original graph. So for the next process, so that we will just we will add the same thing. So s we have to append. Okay, now this is append again. AP node and another thing side this. So here this is 0 and append. H1. Now this is the again here we have removed that s, but after getting the distance we have append that. Okay, because that will work for the another adjacent. So that is the thing. So this loop will run for the all adjacent nodes, and finally we will return a answer. So return as a min of our path weight. What is the path weight? So I hope you know the approach what we are doing. This is the things here. This one. Okay. We can write like this. So this is for the removing the edge. This is just adding the edge again, and after that returning the path. My God, where is the mistake? Mistake we have done. 77. Wait list we are getting. W related is not 0. This is fine. Dot remove s s1. Call this ad node, and we got this in the s. And pathway got append d. Plus h1, then this will append ad node. Ad node dot 0 dot append. What is the mistake? Let's print our wait. Okay, so what mistake is there?
Excuse me, sir.
Yeah.
Yeah, actually, I have a doubt in the 23rd and 24 line. Actually, we are getting SS0, like according to input. So, if you are taking W list of 0, then the whole tuple will come, right? 2, 0, 11 into adjacent. So, our adjacent will be only one tuple, which is 2, 0, 11. Am I correct or am I missing something?
node in W list, node dot append. No, so this W list contain the adjacency list, and this is the source we are getting from the function. So this function WLS, this is the source node. After that, we are just reading all the adjacent values. So the all adjacent will become in this value, correct?
Yes, sir. Like, I mean, what I thought was W list will be in the form of, in input, the second line is there, right? I thought W list will be in that form.
No, no, no. This is not the input, correct? What we are getting in the question, we are getting this adjacency list as a W list.
Okay.
Okay,
Okay,
so
we are getting.
for function, input parameter is actually a adjacent list.
Okay, okay.
Okay.
Okay, sir. Yeah.
So W list, then W list all adjacent we are getting from this source, and source all are appending into the that ADG list as a tuple. We are reading all tuples and we are taking that as a edge, simply copying that tuple. Tuple. I think tuple we cannot update now. Inside the loop, if once is defined, we can assign, but I think that will not correct. That will not impact. Okay. Okay. So W list S. So this will remove the AD node. It is also looking fine. W list AD node 0. So W list 0. That dot remove this tuple to source and AD node let is also fine, I think. Node 1. Then we have calling this test algorithm. Okay. Algorithm and test algorithm will return. Suppose we are calling this distance D, then D we can use as a source. Distance dot plus edge 1. Append. On the tag, I think we not require. Okay. Okay, so I think this is the issue because this AD0. Okay, this vertex we're calling. Yeah, but that is there, I think. That dot append as dot this one. This. It's not getting. Okay, let me do one thing. Let me copy this separately. So one another things we can do, I think some appending or deleting this is doing some mistake. So I'm copying this original disk. We are not touching the original dictionary. So I'll copy this. So that is simply copy dot deep copy. Because this is an adjacency list, so we cannot copy directly. So I'm copying this as a this deep copy. So now do our all task from the OPPE list. Then this is not required. Oh, I think still some. This is there. Pathway, dot append, all these things. Mistake we are doing. Shortest circular route double list as pathway, it is fine. Pathway. D. Mean what mistake is there? I am not sure.
Sir,
Mm-hmm.
maybe we can come back to this later.
So I'm not able to catch the error. Actually, what error is there? So because logic is looking correct, W list as pathway as I'm not for node in this node S is fine. Is append this for it is a node DJ. This is okay. We have copied this list. We have moved this in. Okay. The code is looking fine. Rest of this function call is I think also okay. And AD node is a source node and then pathway D dot S. Okay, we'll check this later. So I think I'm not sure why this is not working and how we are getting this value. So moving to the next. I'll check this later. Okay. 6. We have to manually debug that. Okay, so next, this is related to the binary search. So I hope that is what structure is given. You should know. The structure is binary search tree. That is structure root node is there, and all nodes will be left node will be smaller, and right node will be the greater than this. So this type of scenario. that means you should know the understanding of the linked list concept. So that is also very similar to this. You have to connect all the nodes next field, because structure is also given of the node here. Okay, similar to your linked list, we have this, each node contain the left field, right field, and data field. Okay, if a node is leaf node, that will contain a none, left or right, and will contain the data. So here what it is asking? Insert a new element. So this is simply a binary search insertion method required. So you need to insert a new node in the binary search tree. So that function you need to write here. So insert this function already defined, this function name. We need to write only the function definition of the function. So that is simply. So for this, because every time we are getting a this new node, okay, root is already given. What is the root node? This k value we need to add. So every time we have to create a one new node to insert here. Other thing is simply a searching. So that is just we have to figure out that where we have the empty place. So in this example, we will start from the basic. Suppose if there is no element, we will set our root to that first node. But after that, we will always start comparison from the root. The new element is greater than or smaller. So if it is smaller, move to the left. So in this way, you have to repeat this process. If element is smaller, move left. Then if it is greater, move right. Once you reach at the last position where there is no left and there is no right, at that time you will add that node and that position. So here you need to write the same things. So first, suppose we will create a node equal to that node. So that is class, and inside this we will add this k. So now this is node will be created for this. Okay. So then next step is we will check our first step if our root is already filled or not. So that is if root is equal to or because this is a insert function. Okay, this is a insert function. Then this is not a method, I think. Cell for data, cell for complete the function insert element root this function. Okay. So if root equal to none. So if this is the case, and in that case, what we will do, we will set our root equal to root equal, not equal equal to root equal to node. Okay. Now this is one thing. This is the first condition. Otherwise, in the else case, we have to traverse. Actually, we have to search the position, empty position here. So to search the position, we will just take some that variable temp equal to root, and after that we will traverse this. Okay, so that we will set some okay. So we'll compare our element. So root equal to node, not this node, only this node. None. Okay. So temp is equal to root that we have set the variable. Then we will just run a leaf position. Okay, so to identify the leaf position, we can take some flags. So like this flag to 0, and once we will reach at the leaf, we will change this flag, okay, to 1.
Sir,
So that
we are already given that we have non-empty binary search tree. So I think we don't need to consider that root equals to none.
the implemented variable where each node is created using the tree. Suppose it has a root variable that contains the reference to the root node. The binary search tree complete the function that executes root node, root of the non-empty binary search tree, and an integer k. Okay. The function insert the element k at the correct position of the binary search tree. The function does not print or return anything. Okay. Yeah, that this condition I think it is not required. So we can just try the remaining part correct. Okay, so we can set our temp equal to root, and we can set this flag and we will repeat this process. So also what, we will run a loop like this while, because we have to repeat this process. So while our flag is equal to 0, okay, equal to 0. When our flag is this equal to 0, we will repeat our process. Every time we will compare our elements. So if of our current temp, okay, so temp, or what we have the data is k. So that node k, okay. So if our k is okay, less than 2, that temp dot data, okay. So if this is the case, so what we will do, we will set our temp equal to
temp dot
temp
left.
dot left, okay. And another case is else case, or not else, else elif. Okay, so if another, so here I think that duplicacy will not be there, so that will not be the case, I think. Okay, so elif, so we can take else first. Else we will move over
Sir, won't we use recursion? Like if k is less than temp dot data, then we have to
so
call.
that we are using with the while loop, no?
Okay, yeah.
Okay, so we are doing with the while loop these things. So else part, if k is less than, then we will move to this.
K will not be equal, right? In this.
Else part is not equal. In that case, we will set our temp to temp right. Right. But we have also check. You have to also check this. Okay, so where we have to stop, actually that condition we have also set. So inside the every condition, k is less than equal to temp dot data. So then we are doing this temp equal to temp left. Okay, so first things are also set. Temp dot data and temp dot data is equal to. Okay, we have to stop the process also. So that thing is data case left temp equal to temp dot left. So we have to set one more condition. Now we have to move temp equal to temp dot left. Okay, so none case we have also match, because at the point one thing we can do, I think, while temp does not equal to temp dot next, or that things we don't know where this will be at. What? Okay, this thing temp dot left and this temp dot to right. Okay, so maybe after that we can move to this. If temp, so to if we reached at the last node, in this case,
It is none.
no. So suppose if we are adding one new node like 17, so 17 we have to come from the root. 17 is greater than, so we will move to right. Okay, and still if this is an element, then move to left. Then if there is an element, compare that. It is greater than. If it is greater than, okay. So before moving to the, okay, so here before moving to the left, we have to check like if temp dot left does not equal to none, then we will do this, and else part we have to append that node. Okay, and we have to set the flag to 1. So to add the new node, okay, so new node is this one. So what we will do, so now if temp dot left is not equal to none, then we are setting temp to temp left. Okay, if this is none, then is temp dot left equal to node. Okay, and then we will set our flag to 1. Flag equal to 1. Okay, so same situation we will do with the else part. So that we will write here. So temp, if temp dot right does not equal to none, then we will move to the temp dot right. Otherwise, if that is equal to none, so we will set our temp dot right equal to node, and we will set our flag. So I think our task is done. We check this, it is working or not. It is working. Okay, I hope that logic is clear what we are doing. So
Yes, sir.
we are creating a node, we are setting temp equal to root, flag we are setting to 0, and once we, so our element will be either less or greater than. Okay, so we are assuming that our elements are not equal to. Okay, so we are, that condition we are not taking, our test case is pass. If otherwise, you can also prevent that. If element is duplicate, so just ignore that, do not insert again. Okay, in the binary search concept, we not repeat the element. So in that case, if k is less than equal to temp dot data, okay, so that our new inserted value is smaller than the current value. So we will move to the left, but before moving to the left, we will check if that is not equal to none. That means more elements are there on the left. Then we will simply move our temp to the left side node. Okay, and we will repeat the process. If our temp dot left is equal to none, okay, so that means there is no node to the left, then we can directly connect our new node to the left side. Okay, so that we have set, but we will also stop the process. So we will set our flag equal to 1, so that loop will terminate. Same things we will do with the right situation. Okay, so if right side is not equal to none, we will move our temp to right. Otherwise, we will insert a node to the right. So this is the only concept of the binary search. Okay, for the insertion. Same concept you can use for the searching in the binary search tree. Okay, so same while loop you can use the binary search case.
Searching or deletion also.
Deletion also you can do, but deletion you have to you can okay, so that is difficult, but you have to find out the next predecessor and like this information also. Okay, some more detail will be required for that. If you are deleting any element from the binary search tree, you have to find out a successor or maybe predecessor to replace that part. Okay, that is more that complicated logic, not compared to this inserting and searching. So that is the one. And
so instead of using flag, can we also use break?
yeah, break you can also do loop. Yeah, correct. Just run a while loop with the true condition and break once you inserted it. Okay. Okay, so now this is 5. The problems are open. 5 is this one, 6 we have discussed. This is the 7 one. Okay. So 7.1 is the DP based problem. So that problem actually, okay, dynamic programming. Okay. So what is the question actually? You are given a data in this format. Okay, 1 second. Okay, so let me just copy this then. Okay, so this side, this type of list is given. Actually, this is two lists basically, B A or B. We can say, assume that both of them have the same size. But this type of grid, we can assume that we want to break this grid into the size of like this. Okay, so two either vertical or horizontal like this. Okay, in this way we can just break this into the tiling, and after that for each tiling we will get the score like this. For each tiling support, this is the one tile. So what will be the score for this tiling will be 9 minus 8. Okay, so 9 minus 8. Suppose one tile we are creating like this, and one this, and one this. Okay, so like this one. This is the one possible way to creating a tiling of two group. So that what will be the sum of all? So that 9 minus 8 is 1, plus 6 minus 2 will be 4, plus 7 minus 1 will be 5, plus 3 minus 2 will be 1. So this is the one possible solution. So 1 plus 4, 5, and total 11. Okay, 9 minus 8 is 1. 6 minus 2 is 4, 7. Okay, this is 6. So total is 12. It is given. Okay, but we can also divide the test in this way for the same. So we are taking this time as a like 2 horizontal and same 2 horizontal like this. Okay, then we will get the total score for this. So that will be 8 minus 6 is 2, plus 9 minus 7 plus 2, and 3 minus 2 is now a plus 1, and then 1. Then we are getting total 6. Okay, one way is simply select like this. Okay, can all this. Okay, so then 1, then plus 1, then plus 1, then plus 1, all like this. Okay, and you're getting 4. So here our total task is to getting I think maximum or maybe minimum. So both problem we can solve this. So here our task is to getting maximum score. Okay, so this is maximum score. We need to identify that. So how we can get the maximum score to by selecting this grid in this way. So there are multiple possible way here to creating the grid, but which contain the maximum total sum or total score. So that we need to figure out here. So same things according to the problem, because without checking each possibility, we cannot get the solution for this. Okay, because here there are multiple possible way to selecting the tiles. Okay, so your solution maybe come from any combination, but so here you have to think about the smart approach to solve this. So how you can solve this with the smartly, and just store the solution of the sub problems and use the that same DP approach what we actually generally does. So how we will solve this? So we will start from the smaller problem. Okay, we will start from the smaller problem, and then we will solve this. So how we can start with the smaller, so that you can see we have two lists. So that 8, 9, 6, 7, 2, 1, 3, 2. Okay, now this is the total 4 size we have in the main problem, but we can try with this smaller problem. Suppose we can take like as a empty list, then what will be the solution for that? Okay, then there is no element, then no possibility, 0 is the answer for this. But if we add one more, so like 3 and 2, then what is the maximum score possible for this? In the empty list, there is no solution. Okay, so that is actually a 0 situation. But if we include this one list, then what are the possible combination for this? So we can select like this, okay, and this is the one possible combination only for this. So that is we can select tile like this, and this solution we already know 0. Okay, so that's a maximum to getting the maximum solution we have taken now as a first combination with this. So only one combination is possible. You can directly get the answer for this. Okay, so suppose we are taking this is as a -1, v -1, but this is a v0. This is the solution for this sub problem. So 3 minus 2 we can directly get. Okay, now this is a v0, and after that when we add one more in this, okay, so when we add one more in this, so 2 and 1, now we have a multiple way of the combination. So but now we will store our solution in one another list like this, v -1 or v0, v1, v2, okay, like this. One list we will create for this. v1 we have the 0, v -1, okay, for the empty problem. We have already created 3 minus 2, that is 1. Now we will not calculate this solution again. If we select the tile like this one and this one, okay, so we will not calculate the solution for this. We will directly take from here because this is already solved. Okay, so what we will do, so the solution you will always get like this. So we will either select this, and we will directly get the solution from the previous v0 part. Okay, so that we will add directly. Okay, so 2 minus 1 is the new combination, and that new combination, and what was the previous solution, so that we will add 1 plus 1. This is the one possible way. Another possible way is like this. Okay, just selecting like this way. And what is the solution? So 3 minus 2 is 1, and 2 minus 2 is 1 plus 1. So among these two possible way, vertical and horizontal, what is the maximum? That we will store here next place too. Okay, now every time we will check only this combination. So suppose if we add one more in this, okay, so suppose we add one more in this next time 6 7. So what we need to do, we will just find out this difference, and we will directly take the solution from the previous one. What was the previous solution for this one? Okay,
Previous maximum.
Maximum, and we will select the max. No, we will add first. Okay, so 7 minus 6 is 1, and what is the previous solution if we select tile like this? Okay, so every tile can be take combination like this or vertically. So in this way we will directly get the solution from the previous approach, and we will get the solution for the next one, this one. So in this way we will just smartly solve this, and we will not repeat the process again. So that we will write the solution for this. Let me just go to the solution part, because this I think this problem is not asking for any function. So I think this is also taken from the first term. So we have to read the input directly. Okay, so because this input format is given, we have to read this, and after that we have to perform our task. So here we need to perform all the things by our side. Okay, so we have to read the data first. Okay, so what is the first input is representing n, and another two input is representing the list value, 4 value in the both list. So we will just read first. So n equal to, so that is simply int, and inside the input, so that is the one n value. After that, for the next suppose this is the L1 list, and that this is a space separated list. Okay, so that we will convert that into a list, so that we can use a list comprehension for this. So for I in, okay, now we will read the complete input. So input is, now we are reading that we have to split, or we have to also remove the space. So that first we will use the strip function, so that will remove the starting and ending space, and then we will perform the split function. Okay, so by default this will separate the input by the space. Okay, if we are not passing anything, and for each I after this splitting, we will convert that into a integer. So int of I. Okay. So that is one list comprehension for the list one. Same things we will do for the second list, L2. Okay. Now we got the input. We have read the input. Now we will perform our task. So to perform our tasks, now we have this n value. So that n represent the length of the list. And after that, we will check if our n is equal to 0. So that means empty list, we will directly return the answer 0. Okay, we will return our answer 0, and else if our list is not empty, in that case we'll solve our problem. So we will just maintain a output list here, so that we will take as a answer or output anything. So just create a 0. Okay, so 0 list. So 0 for I, this is not a 0, of that we will take one more here. So n plus 1. So why we are taking n plus 1? Because we are assuming one solution we are taking for the empty input. Okay, so if empty input is there, we are just adding that as a for the solution purpose only. Because we are solving this problem by with the help of smaller problems. So a smaller problem we can take as a empty also. So there is no size, then what will be the solution for that? Okay, so that by default all solutions are filled by 0. So that one is, we will fill the next, we will skip one. After that we will fill all the remaining place. So that is one list is created, and then for next loop I in range. So we will fill from the end side, or we can also fill from the uh, first side also. But let's start with the end, n minus 2 2, that we have to come till 0. So that minus 1 we have to take in, and each time minus 1 size. So this loop we are doing. So I hope you understand that what we have done till now. So that we have created one answer list. So A and S. So suppose n, we have total 4 element in the list. So we have created this one answer list for the 5. 0 1 2 3 4, like this. Okay, so all initially are filled 0. Okay, but now we will update the solution for each this place, and this is representing the corresponding list we are getting in the input. Okay, so that any value 1 2 and 5 and 6. Okay, so in the tiles actually we have 4 value. So for this place we will get the solution at this place. Okay, and for this, then for this, and for this. So this will be the final solution. We will start solution from this side. By default this is filled as a 0, but then we will just include one index values, and then we will get the solution till this position, then till this position, and finally we will get the complete solution. Okay, so we will start this process in this way. So because of that, we are starting from n minus 2. So n is 4, 4 minus 2 is 2. So index. Okay, so that where we are starting, one second. Okay.
Sir, 4 is at n minus 1, right?
Okay, okay. Okay, one. Yeah, that we can also do one more thing, because we know the solution for last empty place. We can also fill one more position. So that is ans and that n minus one. We can directly fill this. How we can fill? Because if we are including only one adjacent, so last this adjacent, if we are including, that is the only possible tile. Okay, so if you are taking like this as a 3 and 2 as a sub problem, 3 and 2, so there is no combination we can make here, because this is the only one value, so we can take tile like this. So this is the a value and a n minus 1, and this is the b n minus 1. So what is the absolute difference between this? So that we can calculate here. So abs like this, a 0 minus a, that, sorry, a n minus
Sir,
1, then b minus 1. Yeah.
sir, don't we have to consider the combination of this n minus 1th value of a and n minus 2th value of a?
No, what we are doing, we are first, we have this original list. Okay, so what element we have? Suppose this, we have this a and this b. Okay, so here 8 6 2 3 and 9 7 1 2. Okay, so this index
Yeah.
value we have given, but our answer is storing like this. So 0 0 0 0 0. Okay, 5
Yeah.
value we have taken. So we are assuming that first we have empty. Okay, so we have filled
Okay.
this as a 0. We are not touching this. Now we are just increasing the size of our problem. So now we have taken this size. Just assume that we have only this problem. This problem.
Okay.
So this is the empty part. It cannot be combined with any combination. So in this case, only this possible tile is there. Only single tile we can make. So this solution we can also fill directly here. So that is 3 minus 2. That is 1. Okay. The next step, we will just decide the approach. Okay, so that part we are doing here. So first step, a n minus 1, we will directly just pick the value of absolute value. So abs in Python, that is l1, that index is n minus 1. Okay, correct? N minus 1. Okay, so that minus, so L2 n minus 2. 1. So I think we will get this absolute value for this position, and that is, result will be stored in this position. Now this loop, actually we will start from n minus 2. Here we need to figure out the approach, how we can get the solution. So to fill this, so for this combination, now for this combination, now we increase the one more size. Okay, include this. In this case, we have the two-way. So either you can make this, after including this, you can make this as a vertical tile. Okay, and directly add the maximum solution from the previous part. What maximum solution you are getting from the previous part? So that means absolute difference 2 minus 1 plus what is the max solution you have already received in the previous part. That you can directly copy from this position. Okay, this is the one way. Another way is just make tile like this two horizontal plus what is the maximum solution till this point, point, this one. Okay, so if you are making vertical, just so far we are just finding out the solution for this position, correct? So if we are selecting this tile as a vertical, so we will add a solution, this previous one. If we are making this solution with the horizontal tiles, we will add the solution with this previous one. Okay, because now this is used here. Okay, this tiles will be used, and then we will add the maximum solution to the next one to this. So this is the two things we need to figure out here. So for the each part of the code. So what we will do, so let's give the name like as a vertical, because if we are considering that vertical tiles. Okay, so for this n minus 2 index, We are just making that as a vertical tile. So to the making this as a vertical tile, so what we will do, we will use this absolute difference of this I. Okay, so we will take this as a I now. I. What is the absolute difference of I? Plus what is the solution of I plus 1? Answer of I plus 1. Okay, so this index we are taking as a vertical in our L1 and L2. What is the difference of this? And plus what is the next index maximum solution we have already saved with the previous solution. So this is the one possible. Another is horizontal, HOZ sub equal to. So in this way we will make this tiles as a horizontally two tiles. Okay, so that I plus I and I plus 1, and same for the first one with the L1. Okay, so L1I plus 1. Second is L2I plus 1. And here we will take I plus 2 with the combination. So absolute difference. So this absolute difference will be for the L1 first. So L1 we are taking first for the I. Then plus, so this is the first list tile. Second list tile we will take as a L2. But this is I plus 1. Okay. Horizontal tile. And then plus answer of AI plus 2. Okay, so this is the two possible situation we have in this case. Li minus this, that L2, okay, 2, this is fine, and this one. So this is the two possibility for the each time, and out of these two possibility we will select the maximum. Okay, so for the answer we will just save as a answer of I. So that I, okay, so that we have to run with the all situations. So that is equal to max of what comma HORZ, these two value. And for final answer we will return only the first answer. So ANS 0. This will be the final answer. Okay, so just take this example and just solve this. Let me take this example, solve with this approach, how we are getting the answer for this. Okay, writing here. So 4 was the total size, and 8, 6, 2, 3, and then 9, 7, 1, 2. So what we have done is actually we maintain this one list. So 0, 1, 2, 3, 4. Okay, this all is filled by 0 first. Okay, now we have taken this as a first as a input. Okay, 3 and 2. This, and we have also mentioned as a we have one empty place also. So that we are considering as a this place. Okay, so solution for that is actually this fourth index, that is 0. But this solution we can directly fill because only this possibility is there, 3 minus 2, so that is 1. 1.
So without that empty case also it will work, right? Okay.
No, actually in the condition in the next situation. Okay, so when we will take next situation, suppose if we will include this 2 and 1, so we will include it 3 and 2 and then 1 empty. Okay, suppose 0, 0 like this. Okay, so in this case we have the solution till this situation problem. Okay, just assume that this is the one problem and we have the maximum solution for that. Now when we are including this also, this also into the problem, so how much way actually we can create a tile? So there is a one way, if we will get the difference for, if we make this as a vertical tile. Okay, so vertical tile, that means 2 minus 1. Okay, and what is the solution of the previous sub problem, this part? Okay, that we are directly adding by this list. So A and S, this is taking. So currently index for this is this was the 3, this is 2 and 1 and 0 that we will again insert. Okay, and this was the 4. So when we will make horizontally, for suppose if we are making vertically, so v2 minus 1, and what is the solution for till this part? So that solution is stored at this 3 index in the answer. Okay, this is 1. We'll directly add here. Okay, so that is answer. So this is just a I position. So I is equal to now 2. We are getting the solution. And answer, what was the solution for 3 stages? So that was the solution till that point. So that we have directly taken. Another way is horizontally. So that we suppose if we make this as a tiles, okay, there are 2 tiles. So here we will take the difference between index 2 and 3. Okay, so that's 3 minus 2 plus this 2 minus 1. Then we have to also add the previous solution. Okay, if we will not take this, so that concept will fail for the first situation because that index is not there. So that will give some error, index out of range like this. Okay, so because of that we may take some empty situation also, and we are just
Yes,
assuming
sir.
that zero solution, and that is answer equal to 4. So that is like, okay, so 3 minus 2 1 plus 2 minus 2 1 plus 0. So that will provide 2. So 1 and 2, which one is the maximum? 2. So 2 we will store here, this. Now if we will add one more in this situation, so that this 6 and 7. Okay, so 6 and 7. Now we are getting the solution till this point. Okay, till one index. So if we make this as a vertical, so that is 7 minus 6. And what was the solution till this point? So that we have already saved 2 plus 2. We will directly add. Okay, if we make this as a horizontally, so this is vertical and horizontally will be 6 minus 2 plus 7 minus 1, and plus what was the solution till this point? So that we will take directly from the list. So that is actually 1. So that will copy here. So 1. And what is the maximum among both? Okay, so this is 1 plus 2 3, and this is 4 plus that 6. 4 plus 6 10, and then 11. So 11 is the maximum. So we will store 11 here. Okay, 11. So now next we will include 8 and 9. So that 8 and 9. So we will just consider as a what is the absolute difference of this and previous solution we will directly add. Okay, so 1 plus what was the previous solution? 11. We are getting 12. It is vertically. Horizontally, if we make this as a like this and this, so 8 minus 6 plus 9 minus 7, and what was the solution till this second index? So that we will directly take in from here. So that was 2. Okay, so in that case 2 plus 2 plus 2, total 6. Okay, so what is the maximum among both? 12. So that 12 will be stored here. 12 will be stored here. So finally, this is solution is representing the solution, complete solution from the last tiles to first tile. Okay, and that is representing the maximum solution. So in the one loop, actually you can see in the solution, we are only using the one loop by this single loop. And in this loop, we are finding out the solution. So this become an order of n time solution. Okay, let's run this.
Sir, return statement would not work because we are taking not taking function.
We have to return from the outside. Huh? Oh, sorry.
You have to do print.
Oh, okay. Yeah, that is not a function. Sorry. And this is from the else part. Okay. Okay, now this is working. Okay, so this is input part, and then this is a DP approach for this. So we are storing the solution in this answer list, and we are using the, without calculating again, we are using the solution of the smaller problem. So
So in this we are going from right to left, right?
right to left.
Okay, but in the question it is given to go from left to right. Like both ways you can do.
Both way you can do.
The logic.
Okay.
Then.
Hmm. So okay, now last problem. Okay, so I think that is already discussed in the live coding problem. B9, that count subsequence.
Sir, still you can, if discuss in brief, that would be helpful.
Okay, so what is the question statement is that we have one string, and that string contain a digits. Okay, so for example, this 7598. So 7598 is just a string, so that s equal to 7598. This is the string, but it contains a digit. So according to the question statement, what is asking? Write a function count subsequence that accept a string s which contain only digit characters. The function returns the number of non-empty subsequence. Okay, that can be obtained from s such that every digit in the subsequence is strictly greater than all previous digit if exist. So that condition we should follow. Okay, so how many subsequence we can made from this type of situation. Okay, so here what are the subsequence? I hope you know the subsequence meaning. We can take any the character combination, but order should not be changed. Okay, so like 7 is the one possible subsequence for this, because this is single digit, so no condition is required that greater things is. 5 is 1, 9 is 1, and then 8 is 1. So these 4 subsequence is fine. But if we take combination, okay, suppose 7 5, this we cannot take because here second digit is smaller than to the first digit, so that should not be followed. But D1 D2, suppose if we are taking these 2 digit, so D2 should be greater than to D1. This should be the condition given here. Okay, so 7 5 we cannot take. 7 9, yeah, this we can take. Okay, because 9 is the greater than to the 7. Similarly 7 8 we can take. Okay, because here this is also satisfy the condition, so this is also correct. Same things 5 9 we can take, this is also fine. 5 8, this is also fine. Okay, this is also correct. Okay, so 7 7 5 9 we cannot take because this is not following the sequence. 7 9 8 we cannot also take. Okay, 5 9 8 we can also not take because here this is the unordered situation. Same 7 5 9 8 we cannot take. So all these are incorrect. So how many possible combinations are? 1 2 3 4 5 6 7 8. So 8 possible subsequence are there which follow the constraint according to the problem, given problem. Okay, so you can see the solution is given 8 for this, and explanation is also given in the same way. So how we can count this? So if any input is given, so like this is the first test case here, this is the big test case. So how many possible combinations are there which follow the things? Okay, so here we can also think about the DP approach, and that DP approach we have discussed last in the live coding previous week. So in this case, what we will do, we will just maintain a list. So that list, suppose this is the answer list, and that list will contain the solution for each digit actually. 0 1 2 3 4 5 6 7 8 9. Okay, so any number can be so any digit in the strings will be coming from this digit. Okay, so 0 to 9, and this index we can use as a increasing order. Okay, so this index is actually increasing in the increasing order. Okay, 0 to 9. Now we can store the solution for this like this problem 7598. Okay, so 7598, this is the strings we have. Initially we set all as a 0. Okay, now we will take 7 first character. Okay, first character we will take, and we will count that how many solutions, how many subsequence we can made from this 7 if we are taking this as a sub problem 7. Okay, so you can see till 7 there is no solution we have received because there is no digit before this, so all are 0 initially. So for save, this 7 is matched with this 7 index. So because there is no value previously are there, so to get the solution we will add all previous solution. Okay, but here all are 0, so 0 plus till this point all are 0, and but we can make one subsequence as a single digit, so we will add 1 here plus 1. Okay, in this, so that will be updated as a 1. Okay, so I hope this is not clear by the first digit, but now let's move to point to the second digit. Okay, 5, just increase this as a 7 5. Now this is the problem now. Okay, so how we can make the total solution from this? So we have already find out the solution. If we have this problem 7, only one answer is there. Okay, one subsequence we can make 7, but if we make this as a 7 5, how many subsequence we can make? So for 5 is now coming, so before 5 you can see 5 is this, before 5 there is no digit is actually occurred till now. So same things, we will add plus 1 here, so that will be the 1. Okay, so that means you can make, for this problem you can make total solution is 1 plus 1 2. Okay, total solution will be calculated by adding all these value. So so now total subsequence are possible with this input is 7 and 5 single digit. We cannot make 7 5. This is not following the rule. Now let's take 759. 759. Then how much solution are possible? So for 9, this digit. Okay, now we will check how many solutions are previously available with this. Okay, so that is actually 1 plus 1 2, and 1 can be made as a single 9, so that is 1. So 1 plus previous 2 is total 3. So 3 combination we can make with this, because with using the previous digit, so with the help of this 9. Okay, so total combination now made as a 5. How we can made as a 5? So 7 is there, 5 is there, and 9 is there. Okay, but we can also use this 9 after the 7. Okay, so 7 9 like this. Okay, and also 5 5 9. Because of that we have added previous solution also. So this is the solution till 5 and till 7, but we have also added this 1 plus 2, this previous solution. Okay, because we can make the combination with these 7 and 5. So now total solutions are 5. Now add the same 8. So 7 5 9 8. So in this case just check the 8, and till 8 how many solutions are there? 2, and 1 is from single 8, so that again 3. 3. So that means one solution you can made with 5 8, one is 7 8. Okay, both following the rules. So now 3 is there. So how many total solution you will get? Add all these. So total 8. You can see 1 plus 1 plus 3 plus 3 8. Total 8 subsequence can be made by this. So this is the approach we can use, and this is also a single loop we can perform. Not single, but yeah, we have to check all previous solution till that point. Okay, every times when we are traversing the digit. So how we can write the solution for this? Okay, this is the, what is the function name? Count subsequence. Okay, this is already given. Okay, so this is the input. Then we will made as a one empty list, and here, and our size. What is the size for this string is? So that will represent a number of digit also. So that is len of s. We can make. Okay. Now what we can do? We can just identify the all that digits, and we will append all digits into the list. So okay, so that will useful for us. So that means for each character, okay, so for each character in the that s, we will convert that into a digit and append into the list. So l dot append and that int of c. Okay, so now all digits are actually added into the list from the string in the integer form. So now next step is now we will create a one complete list. So that will contain a 0 to 9 index, and each value will be the 0. So that we will use as a that count information. So we are just counting, and we will create a 0 list for this. Okay, so 0 for 0 for I in range 10. Okay, so for each index we have done this. So that is created a 0 list for all index. Now we will do our task. So for I in range of that n list. So n is our total. Okay, so how many elements digits we have? So total n digit. Okay, for each digit we have to check this. So for each digit we will perform this for j in range of this range. Okay, so that range will be start from 0 to that what is the digit value we have. Okay, so that is actually li. Okay, so that digit is storing in the li. Till that point we have to add all the value inside this, and we will store. Okay, we have to add, okay, that all value. So we will store our value to in our count. So count, and where we are storing this data, so that is I place. So that I place, not I, sorry, li. Li place we are storing this, so that is equal to plus equal to uh, each j value. So that is actually not count, and inside this we have this j index count j. So this is now reading all the solution from the previous digit, all previous digit which is coming till this the current digit. But one we will add for the single, as a single character solution. So that we will write as a count of this, the same things we will write here, plus equal to 1. Okay, so now this loop is done, and so our all data will become, and for the result actually we will return a sum of all. So sum of all, just return sum of complete list, not this count. Okay, this list, so that will be the return things. Okay, what is the mistake? Name S is not defined. Oh, capital S is there. Okay, that is working. Okay, so same approach we have done, which we have explained here. So 0 to this count. Here we have mentioned ANS, but we are taking count. So that is we are maintaining, and for each digit we are adding the previous solution till that digit, and +1 for the single digit, and that will contain the all subsequence count.
Could you please explain the logic once again? Why have you created the digits from 0 to 9?
Okay. Because in our strings, what digit is possible? 0 to 9.
Yes.
Okay. So we are just maintaining the counting in this digit. So that means if we are we are getting any digit. So before that, what digits are coming? All digits are smaller. Okay.
Yes.
So because all the index here are in increasing order. So if we are getting any digit in this index, and if we have already found the digit before this, okay, so suppose we are getting like 1 5 6, okay, so that means this is already come before this, and we are solving the problem as a smaller problem with the start first digit. We have already find out the total solution for this one, okay, and we have mentioned the solution here, one, and we now that increase the size of problem with the next digit, so 1 5. So if this 5 digit is coming after the previous digit, which is already smaller than this, so that already contain the solution. How many solutions are can be created with this smaller digit 1? So that we have already stored in our resultant list. And when we are just using the current digit, so we will directly read the previous combination. So how many combination we can make from the previous digit, which is smaller than this. So that is already coming before this. So 5, and that means one subsequence is made with the help of this, and this can also made with this current digits, because according to the constraint, uh, every digit should be the greater than to the previous digit in the subsequence. So that is already fulfilled by this increasing order. Okay, so because all digits indexing we are using as a digit, that is already in increasing order, and every time we are reading the solution from the previous digit, what digit which is coming before that. So that will make the subsequence with the combination of the current digit. So because of that, we are adding all the previous solutions. So here you can see one, if one is already created one subsequence before that, that can also make the one subsequence with this 5 also, 1 5. So because of that solution we are directly adding using from our previous solution. We are directly adding the solution to the current solutions. So 1 by default as a single digit, but we will also read how many digits already occurred before that in our approach. So that we will directly read add here without counting all the combination again. So
against 1, what have we written?
so that will again increment the counter. Okay, so suppose if this type of situation is come 1 1 5, you are saying this. Okay, so that means in this case, 1 is coming first time, so this will increment 1 time. Okay, if this is coming second time, so second time we always read the solution from the previous digit which is coming, but here again the 0 is there, so that will make one more addition in this. So 1 is there and +1 2. So how we are getting 2? 1 is the this digit, okay, because these 2 1 are separate 2 digit, so that will make a different subsequence. So that means this one is the separate one, this one is the another one, and then this is the 5, then 1 5, then 1 5. Okay, so this one is this first one, and this one is the second one. Okay, so each single value will be considered as a two different value if it is occurring more than one time in the subsequence. So count will come correctly if we have the multiple repetition also. So we will not consider this as a same, because here this one is not actually taken from the same position. It's taken from the different position. So that will make a different subsequence. So that will come in the count. Okay. So any other sample you can take here. Suppose if you are, this is not clear. So let's this is repetition. Okay. But I think we can take this. Okay, so this is the input, and let's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now 1, 1, 1, 3, 2, 4, 3, 5, 5. This is the input. So first one will increment this value. Okay, so 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So here total ones are 3. So each one are actually separated one. Okay, so this all 3 1 can make 1, 1, and 1. These are 3 different subsequence, not the same. So here if we take 1, so that will increment the count 1 here. Okay. If we take second one, then again, because there is no previous information is there already, so that will not, if you will add all this, which is 0 initially here. Okay, so that will make 1 and plus 1, so that will become 2. The next one will become 3. Okay, now 3. When we will take 3, so 3 is now this one, so that will read 3 and plus 1, so that will become 4 here. So that means 1, 1, 1. These are the 3 separate one, and 1 is 3. This is the 4 subsequence. Then 1, 3, 1, 3, 1, 3. This will also come. It's separated with all 3 separate one as a count. Now 2. If we take 2, so 2 will also come with 3 plus 1. So that is also 4. That means 1, 2, 1, 2, 1, 2, and 1 is single 2. Now this is 4. Okay, and now if it is repeated 4, so 4 will come as a 4 plus 4 plus 3. Okay, so 8 plus 3, 11, and then 1, 12. So that this 4 can make as a 12 combination. So one is single 4, another is like this 1, 3, 4. Okay, 1, 3, 4, 1, 3, 4, and one is 3, 4 only. Okay, and another is next this 2, 4, and 1, 2, 4, and 1, 2, 4, and 1, 2, 4. Each time this 3 will be, 1 will be repeated 3 times. Okay, so that is making the subsequence. Next 3 is there, so 3 again is coming. So same thing. So 3 is now coming at the later stage. So that will actually increase 1 only. Here. So not. Again we will check here. So how many combinations are there? Yeah. This for this 3, how many combinations are there? So we will check 4 plus 3, 7, and then plus 1, this 3. Okay, 7 plus 8. So this will become 8 now. Okay, and then this 5 will read all the previous values. So that 20 and 24 and 27, then 8, 28. And one more time. So that again, so that will, you will get the same thing, and plus 1, 9. No, okay. So 5 equal 29 this way. So in this way, you, and now later you can add all this. So this will be the total subsequence. Yeah. So that in this way, this approach will work. Okay.
Yes, sir.
Okay. So this is the solution for this last problem, and yeah, we got some issue in the
question 5.
Question number 5. So still I'm not sure what was the issue in this. I think how we are getting this 324. What test algorithm is written? One second, let me print this DS also. Okay, so what is the print? D. Okay. I think this direct algorithm is not working correctly. 0 to that one index. For 0, this is representing 313. How this is possible? WL is this one. Trash algorithm is also returning some feedback.
So there is also one tuple, right?
Where?
Like the D. This one, that should not be there.
I'm printing after that. Okay, now this is coming. So this dictionary distance dictionary is now coming. So 313. So we have passed as a first adjacent of this node. So this is 201. 0 was the given. So 0 say 2, 0 to 5. 2 adjacent are there. So from the 0, 2 and 5. So if we are calling this from the 2 to 0, should we by the other part? But still this is not possible. 2 to 0, 313, how it is coming. Infinite. So what is circular route? WL copy WL source remove AD node tuple will be removed here. And WL this AD node 0. 0 is the index for AD node. Dot remove this is node 0. Pathway dot append plus AD dot 1. Our summary. Yeah. This is the same approach I think we are using.
Excuse me, sir.
Mm-hmm.
Here in this algorithm, the S in the above one, the above definition, S is a node number, right? I mean integer, which we are passing in the algorithm. But here we are passing AD underscore node. That is a tuple.
Oh yeah. Okay, correct. Okay, that was the mistake, I think. Yes. So I think it's this zero node we need to pass here. Yeah, now correct. So if you remove this, pass. Okay. This was too much. Yeah, pass. But still, it is handling. Actually, I don't know how it is. Actually, algorithm is working on this tuple. But tuple we are getting here, and still algorithm is working perfectly and return the output. It is not giving any error. Yeah, thanks for pointing this. This is too much time for the debug. Okay, otherwise approach was correct. Only we missed this issue. So here we need to find out a source vertex, but we passed as a tuple previously. Because of that, it was giving the correct output. Okay, so this is the correction on this. So this is solution. Okay, yeah, thanks for this correction. Okay, then any other query? Already
So the last mock, can you?
last?
Yeah, mock.
Okay.
No,
This
so
one?
here in the question they're asking increasing sequence. If they had asked for decreasing sequence, then this second for loop we have to change, right?
Decreasing sequence.
Yes. Then for j in range, L of I2, then last. L of I2n.
Then you have to change the approach, but you have to set the value index accordingly. Then
So instead of going from 0 to Li, we should go from Li to n. 9.
Li to 9.
Yes. Like bigger digits.
Li plus 1.
Yeah.
Li plus 1.
Li plus 1 to that last digit. So
Only that change, right?
let me check this 7589. And you are just showing that if digit should be that is smaller.
Decreasing.
Previous digit should be smaller like this. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, how many combinations are there? So these 4 are there. Then with so 7, 5, 8, 9. This is the fourth one. Okay. After that, say increasing order. Okay. So 7, 8.
No, sir, I think
No,
I also go
decreasing.
from n.
7, 5. You are saying decreasing. Okay. 7, 5 is possible. And nothing is possible now. In this.
8.
No. We cannot. Subsequence we cannot read like this. Okay. Subsequence we cannot change the order. So only this 7, 5 is possible in here. So let me check we are getting this way correctly or not. So 7, that if we are getting 7, then we are making 1, then we are getting 5. Yeah. So we will read the data from this side. Yeah, correct. So 1 plus 1, 2. And then 8. So that is 1, 9. This is 1. So total solution now 5. Yeah, correct. So in this way we'll get the output.
They change that only that inner for loop, right?
Ha.
Rest everything will be same.
Will be same, yeah.
Sir, just a general doubt. I want to practice the GRPAs of all the weeks so that for the OPPE. But how can I practice that, because the due date is passed and now I can't submit and check for test cases, right?
Yeah, there is no solution for this.
Yeah.
We cannot open this graded assignment now. so that you can only solve, because I think all the test case and all things are open, so you can also test, you can check your code with the another editor also.
Okay, manually
So
applying the test case.
just copy the test case and check the corresponding output is coming or not.
Can I get access to the public test cases?
Public test case,
I
I
mean, sorry,
think
private test cases.
that is, I think, already visible now.
No, private
Not
test
visible.
cases are not visible.
Okay, so it is visible.
Oh, okay.
You can access.
The solution
Okay,
means
sir.
you'll get the
Thank you.
correct code, right?
Hmm?
Solution means we'll get the
Solution. This is the solution which is
okay.
configured. Which is the configured actually our from our side. So your solution will come on the right side.
And sir, this last mock that we discussed, can that level of question can be there in OPPE?
Yes, so I'm not sure the exact difficulty level, but yeah, this type of questions will become. So because this is also one of the OPP question. So just practice on that live coding problems also. Okay, so DP problem which we have discussed in the last
Yes,
week.
sir, yes.
Okay, and weekly assignments, but not too much difficult we will provide. Otherwise, you can also apply some recursive approach. If you are not able to figure out the DP solution, you can think the recursive approach also.
Okay, sir.
Okay, so that is also another way to solve the same problem. But because a DP problem, we will not check the time complexity. Okay, so that problem can also be solved in a different approach, some big complexity like this. So you can also apply.
Okay, sir. So in OPP, we can expect questions from level easy to hard, right?
Easy to hard, so that linked list question will be easy. Graph, if you know the graph algorithm, that question
Yes,
will
sir.
also be easy. But DP questions, you have to come out to the logic approach. Binary search based questions, maybe you have to think about the logical thing. Other some greedy approach. Yeah, you have to come at least 2 questions you can
Okay.
expect, where you, if you are prepared well, you can easily solve.
Okay, sir.
Okay,
Thank you.
algorithm and linked list this.
Okay, thank you, sir.
Okay.
The
Okay.
difficulty will be similar to OPP, that mock.
Mock is more difficult compared to the OPP. Okay,
Okay,
because this is the initial term question, so because of that, these are the tough questions. But now the level is reduced.
Okay, sir. So we can expect like little bit easy compared to mock. Okay, so like the DP, it's the tile. Those were
This is
difficult.
actually, this is not a easy task. Tiles questions is not too much easy. This is just a competitive problems. Okay, so that is used in the first term, but now we use some simpler problems.
Okay. And sorting will not be there.
Sorting you can do with the sort function, the Python. Some concepts come. This is like this merge sort of merging two lists, sorted list, that use the sort concept of merge.
Only merge will come. In merge sort, only merge. Like two sorted list will be given and you have to merge. Like
yeah. Yeah, Bhumika.
Sir, now like we have only 3 days left, so we should practice the lead code or just should revise the live coding and the mocks problem.
So as I mentioned that practice on the linked list questions, just learn these 4 algorithms which I mentioned, BFS, topological sort, and one algorithm from the shortest path, and one from the spanning tree. So at least learn these 2, so you can solve 2 problem at least by this. For remaining problem, that DP you can practice, okay, on the any platform, lead code platform, or that course problem also. Okay, so DP will be helpful if you practice more. Another problem, yeah, you can try sub-binary search based problem. Otherwise, this course problem is also fine. This type of problem, actually, we cannot say that if you are solving all lead code problem, you will be able to solve here, because problem may be new. You have to think from the scratch. What is the logic? That is the things. We cannot say that if you solve all the lead code problem, you will be able to solve here also. But yeah, if you are practicing more on any place, or if you are solving all problems of our assignments, that will be helpful.
Okay, thank you, sir.
Okay.
We may need to have to solve this like Dijkstra and all. We need to write there, or it will be given. We have to, based on that, we have to solve something else. Like just we did something.
If problem is totally depends on the algorithm, then you have to write the algorithm. If problem is required some another logic, and with the help of this algorithm, so some code will be given to you. Okay, so also algorithm is also required in some problem. Okay, so just learn the algorithm also. You have to maybe write.
Okay, and we create the nodes. There will be a class, or like we create the
All
queue
information
class.
will be
Those things?
provided in the question itself.
Okay, those will be given actually.
So if that is required, the information will be given to them.
Like queue also will be given, sir, or you'll have to use?
No,
Depends
like I
on the
mean
problem. It depends on the problem. If it is so, actually, we have decided the task. What actually you need to do in the solution. So if solution require more implementation, and that will be given to you as a prefix or suffix. So that means you will be able to complete all the problems in the 2 hours. So because of that, we have decided some prefix suffix already implementation given in the questions. So if solution is big, then we will give some part of the code already. If solution is small, then we will not provide any solution part. You have to write.
Like queue and eeps, those things.
So suppose if BFS algorithm you need to write, so maybe queue implementation is already there.
exactly, that is what I want to know. Okay.
And
Yeah.
for algorithms, it will be enough if you read BFS and Dijkstra's and one.
What I mentioned
BFS.
here, you can just practice.
Okay, sir. And DFS.
As you were saying BFS, so DFS is not likely to come. Is it like that?
DFS is not too much important. Same things you can do with the BFS also.
Okay.
Sorry, what did you mention? BFS, binary, and linked list, and
No.
Dijkstra.
In graph algorithm, graph beak 5 and beak 6, at least learn 4 algorithm: BFS, topological sort, any one shortest path algorithm, any one minimum spanning tree algorithms. Okay. So at least learn these 4 algorithm. One problem you can solve if you know these 4 algorithm. Another is linked list. Just practice on the linked list. So that insert, delete, traversing, you can solve that problem also. Another problems will be based on your practice.
Okay.
I can't give more hint. Okay. Already mentioned many things.
I don't think even if you give a hint, even then it's tough.
There will be something related to like this for week 1 and week 2, like that.
Label? What things you are saying?
I'm asking, there will be questions from week 1, week 2 also.
Week 1 was
Like
Python
searching
actually.
and all.
Searching maybe there. So I have already mentioned, no, binary search
Or
question
sorting.
will be there.
Okay, those will be there. Okay.
Week 1 was the Python, so Python by default actually.
Sir, in mock,
I
first
mean week
question
2.
was
I mean to say.
Python.
So what will be the difficulty level for the linked list type questions? Like mock and the live coding will be enough?
Yes, enough.
Okay.
Sir, and also there was a Python-based question in mock question one, so it was not based on any algorithm. So those types also might come, right?
Yes. Slowly you are asking everything. Okay. Okay. Any other query? Do not ask any more hint. Okay. For the questions.
Okay, sir.
I've already mentioned enough.
You actually have not mentioned anything. You're just trying to know.
No, two questions I've already mentioned: linked list and graph algorithm. So 50% paper is I've already mentioned, but remaining 50% definitely.
Mentioning is of no use. The problem is so complicated. Even if we know the whole algorithm, if we're able to solve it, it's a big deal.
I think no, it will be easy. Okay.
Okay, thank you, sir.
Okay, yeah. Thanks. Thanks
Thank you,
everyone.
sir.
Bye.
Thank you,
Good night.
sir.
Thank you.
Good night.